Okay, hello everyone. I'm Mohammed Shahriar, almost like a middle. So we are starting our KCD Chattogram today. Okay, so let me share something with you before starting the stream. Feel free to let me know, like if you can see my stream or not. Please let me know if you can hear my voice. Okay, so we will start with something from a slide sharing. Before starting, let me share screen. Okay, great. Okay, I think you can see the screen. Right, let me check. Okay, great. Please let me know if you can see my screen or not. Okay. Rahmatullah mentioned not. Yeah, great. Okay. I'm sharing a Mentimeter a link here. You have to just use the code and you can get in. So please do use that. I'm sharing that. Okay. I provided the Mentimeter link as well as the code. Okay. So what are we doing that? Basically, I'm going to work with it. Like, how can we run this? Let me check. Okay, so what do you understand by cloud native? So that is the thing. So whatever you understand by cloud native, you will just put in out here the words related to cloud, whatever it is. Maybe you can Google it or whatever it is you can do. Just let me know out here. So it's just a quick thing, like to know about what knowledge you have. After that, we will talk about something related to KCD Chattogram and so on and others, and then we'll start our stream main event. So please join in and please let me know if you can see this Mentimeter link or you can join in. Okay, I can't see any response yet. Yeah, we are waiting for your responses. So, what is cloud native today? We are basically starting the KCD Chattogram. It was supposed to start maybe from, I would say, 6, but we're starting from 6:30. So it will be live till link broken, right? Okay, you can just go to mentimeter.com. You can just Google it. Okay, then you use this code. Okay, 16. You can see 16294217. Okay, you can then get into this. Is someone verify if that works? Let me check a bit. Okay, from another browser. Mentimeter. Just look into then 1629 then 4217, right? Check. Yeah, I can see that. If you just Google it, okay, if you just Google it like Mentimeter or something, and then go there, and in the website you will see that in the beginning you will see there is something for the code. You will just put in this code 16294217, and you can just um, join these slides. Okay, please let me know. I can't see any screen. I just checked it out in my another monitor, so it's working fine. Okay, let's talk about it. Let me share the link again. Okay, here's the Mentimeter link. I have again shared that. Feel free to go here. Okay, great. Yeah, good. You can just go there and share the words. Kindly share the issues. If you are facing any issues, feel free to let me know, and I will be here. Wait, Mentimeter, and you share this one. Okay, see. I'm curious to know. Okay, we will get into that later on because I think few folks are facing some issues. So let's talk about that. So that's the answer. Cloud native computing. What it is? So it is basically an approach in software development that utilizes cloud computing to build and run scalable applications. So I'm assuming you will get in and you will fill in that boxes once you get in. Okay, please let me know in the comment section. Okay, so to build, run relatable applications in modern dynamic environments such as public, private, and hybrid clouds. Okay, so this is basically cloud native computing. Okay, great. Now, talking about have you joined the CNCF Chattogram or not? Please add that, like if you have or not. Phil, let me share the link by now. To okay, so the community link. I will talk about it though. Like okay, so yeah, great. I think now folks are able to uh, share their opinions. Great. Mentimeter taking too long to. Okay, that's sad. Okay, let me. Okay, join a cloud research program. Here it is. If you haven't, I've shared the link in the comment section. Feel free to just join in. That's great. Okay. Okay, that's great. You are joining. That's great. So let me talk about it. What is cloud native and how to create a community like that? Okay, so we will talk about CNCF projects in I mean within a few moments, or what it is, or landscape, whatever it is. The thing is, CNCF is a big organization. Like here we the CNCF, we have lots of contributors out here. I'm not a part of the organization, but I'm a contributor and a maintainer of projects. So the thing is, the project maintainers or contributors do can actually apply for the community groups. Okay, so Chattogram is one of the community groups. Previously, we have uh, actually taken an event which was KCD Dhaka in May, back in May. So that was in person, but this time this Chattogram event is online, depending on lots of situation we have gone through, right, in August and so on. So we have thought of like going for online versions. So this is here it is. So this is KCD Chattogram, and basically these communities do arrange events and so on. Okay, okay. Let me go to the next slide. So here it is. Here is the sense of landscape. Now, what it is, you may search in YouTube like what sense of landscape is or so on. You can just search for into the Google like sense of landscape. You can see that. So there are lots of projects and which are currently part of CNCF and other companies. So there are lots of contributors who do contribute to these projects. So if you want to be part of the community, what you have to do is you have to like you can contribute to the CNCF landscape projects. Okay, I think it might seem like it might be some sort of blurry out here, but what you can do, just search in the Google sense of landscape. You can go out here and you will see the whole landscape, and even when you press the landscape like projects, you will see like you will be moved to GitHub and so on. Okay, so you can just see what this project is and so on. So there are lots of project you might have heard about, like Kubernetes, right? That's a very famous project. So this event is all about like Kubernetes community day, but we're not limited to just Kubernetes. This event will be a lot of like covering the open source projects since it has and so on. Okay. Okay, great. Now talking about another thing, which is recently, like in the November, we have a big KubeCon event coming up. Okay, in Salt Lake City, USA. So if you want to join in, you can just go there. But when I'm going to start this session, like after the slides, I'm going to start with the KubeCon 2023's video, so that you can see how the community is around there globally. Okay, how well, many people do join these events and so on. KCD is a small version of the KubeCon. KubeCon is a huge thing, like maybe 10 to 12,000 developers do join it. So yeah, that's the thing. Now, here are the organizers, although this might seem blurry, but here are the organizers for the KCD Chattogram. We have obviously me, then Amir Bhaiya, then Arif Bhaiya, then Nasiruddin Bhaiya, then Mohammad Abdul Aziz Bhaiya, then Joshim Alam, MD Hujratun Ali, and Journal Abidin Mia, and Sabir Imtiaz. So you can just know about the KCD Chattogram. Just go to like this link, community.cncf.io, then KCD Chattogram, you will know about it. Great. Now, important notice, that is quiz rules. We have quizzes, we have prizes, so we have to obviously we'll give away those prizes. So how? The thing is, we will start our mm, sessions within a while. So after each session, especially after the sessions from 7 p.m, we, after each session, like it will take almost 30 minutes. After that, we will run a Q&A. You can ask questions. Depending on your questions and feedback form, we will give away like a few prizes, maybe two. And depending on the quizzes, we also have actually prizes. Okay, so there will be like three quizzes as a whole. So you will, the first winner, the winner will actually get prizes. Okay, so what you have to do, once the session ends, I will mention that yeah, it's a quiz time. Then you have to go to mentimeter.com. We will provide a link of just like this one, a code. You will just put in that, and what will happen is you will see the questions in this screen, and you have to choose your answer from your mobile or any device you have joined in using Mentimeter. So then that's it. So you have to keep in mind that you have to answer correctly and you have to answer quickly. That's how things work. And these questions are provided by the speakers. So you have to understand that whatever the question is going to be, the answers are within the session. So you have to attend the session to answer the quiz perfectly. Great. So I think here we go. We can start our KCD Chattogram. Okay, let me stop the sharing. Great. But before starting this one, I will start with Audra, our KCD's program manager. But before starting that, I will start with this one, how the KubeCon looks like. Let's.
Welcome to KubeCon.
This is the place to be.
You might feel like underrepresented in your country, but when you're here, you feel like you have friends.
So it's always like this coming together and reconnection opportunity that I just love. Look forward to it every year. I really love attending talks. I'm really excited this afternoon to go to a couple more. I think that's going to be the highlight of my day.
Kids come to KubeCon Kids Day, they get a t-shirt, they get a badge, and it already makes them feel like they're part of something special, something big. These are our future technologists, engineers, and this is where it starts. Because you never know, one workshop could lead that kid into a whole new direction. That one spark is all they need.
My favorite things at KubeCon are the stickers. I came here just for the stickers.
Getting to be face to face with people who are typically on the internet has been a really fun, great experience.
I can't wait to see you at the next event.
See you at the next KubeCon.
Sorry, my bad. Okay, that's a KubeCon, and that does happen like every year. So every year, Cloud Native Computing Foundation arranges like 3 to 4 KubeCons. So we have KubeCon in November in USA, Then in December in India, and obviously next year we have in London and maybe in Japan as well, and so on. Okay, so there are lots of events. You can just go to Linux Foundation events and so on, or just search for KubeCon. You will find out all of those. Okay, so I think we can now start with another session, which is very important and start of our session, like which will be taken by Audra, which is our program manager. So let's start with Audra.
Audra Montenegro. And hi, folks. Welcome to KCD Chattogram. My name is Audra Montenegro, and I'm here to speak to you about the community impact on the CNCF ecosystem. Prior to CNCF, let me tell you a little bit about what I did. I worked for O'Reilly Media, another open source company that actually were the first to publish quality program language books back in the late 70s and early 80s. And I actually had the chance of meeting folks like Kelsey Hightower and Priyanka Sharma back when I was working as a speaker manager for the content of these events, which were global. I basically was a project manager with the program committee and the program chairs. But yeah, for those of you who don't know Kelsey Hightower, you should. He is a key figure in the community who worked at Google for a long time and helped to bootstrap the Kubernetes community, became a principal engineer, and now he is traveling around the world simply speaking on Kubernetes and other cloud native topics. And Priyanka Sharma is our director here at CNCF. And I had the pleasure of meeting her back when she spoke at these events like OSCON, the open source conference, which hosted about 6,000 people annually. Who am I today? Well, I'm a program manager who works on two programs, community oriented, of course. One being this KCD program, Kubernetes Community Days, and the other being CNCGs. So these are cloud native community groups. But I joined the CNCF back in 2022, and I'm basically here to provide guidance as well as resources to the global community. All right, who is CNCF anyway? I am bringing this question to you because we are humble and we know that we are not known around the world. Everybody knows Linux and the foundation and the projects underneath us, but not necessarily the Cloud Native Computing Foundation. Well, let me tell you, we were founded 9 years ago in 2015 under the Linux Foundation umbrella. And basically we focus on cloud and cloud computing. And this kind of came out of the donation of Kubernetes project from Google. But we foster this ecosystem of open source and vendor neutral projects, bringing together the world's top developers, end users, and vendors at large events like KubeCon and Cloud Native Con or Open Source Summit. So why should companies use Cloud Native anyway? Well, it makes your company more efficient, resilient, allows you to use multi-cloud, and my favorite is higher development velocity. And if you don't even have an OSPO, an open source program office, I highly encourage looking at todogroup.org. This is a great place to do your research and present to a technical lead on why it could help your company scale and, again, provide higher development velocity. All right, so how do we make innovations accessible at CNCF? We do this through a technical oversight committee, which leads our technical community, our governing board that manages the business side of things. And then we have members. We have 750 members to date from all these different tiers listed on the slide. And then our ambassadors. Believe it or not, we are a small team at CNCF. So our ambassadors are our arms and legs, helping further the mission of Cloud Native through leadership and programs like this. And then our projects, of course. So you're likely familiar with one of the 204 projects we have at either graduated, incubating, or sandbox levels. But if you're not, take a look at the landscape, landscape.cncf.io to learn more. It's actually been rejuvenated. So there are tabs strictly on projects, and you can manage by topic area. Then there's our member tab, and then also a statistics tab. But our projects cover any of these topic areas: provisioning, runtime, orchestration and management, application definition and development, of course, observability and analysis, so more on the data side, and then platform. Now, what does it take to sustain a project in the cloud native ecosystem? Well, you have maintainers and contributors, and then of course our technical oversight committee that oversees all of them. So 1,610 maintainers to date that help make the project run smoothly through managing the code, defining its values and goals, and then of course managing the community. And then 13,000 contributors, or just about. So these folks aren't consistently maintaining the project, but they might contribute a pull request that gets approved to help better the project. And if you're interested in contributing, well, clotributor.dev is an awesome website. It's like a job board for projects, for cloud native projects. But Clo is in cloud native, contributor is in contributor. It's a great place to get started, and there are different roles out there that are needed within these projects. So have a look. And if you're very new, we have a mentorship program or others that we recommend. But there's a lot of opportunity here to figure out what your goals are within the ecosystem. And then, of course, working alongside folks that are experts in helping make cloud native ubiquitous and being key influencers on these open source projects around the globe. And then also your mentees, working alongside other eager, motivated mentees such as yourself. And then finally, we do have some recognition opportunities through incentives or stipends, depending on the program. But also recognizing you as a contributor too is a huge piece. So whether that be badges or promotions through Humans of Cloud Native, just check out these programs, see if you're interested. Again, there's 3. So LFX Mentee Program is the Linux Foundation one. And then also we have Google Summer of Code that we point to, and then Outreachy as well. And my favorite topic here, community events. Favorite topic because I run these 2 programs, as I mentioned earlier. What do attending community events do for you anyway? Well, you build your connections, then you learn, and then you could advance your learning from there and even get certifications. And then sharing your use case if you're a little bit more advanced in your cloud native journey through speaking opportunities, which eventually get you into teaching, mentoring, writing, whether it be blogs or documentation, or really active on social media. There are plenty of ways that these community events can help advance you. So let's dive deeper into the community groups. The meetups are a community event, and you can check out one of the 193 active chapters that are showcased on community.cncf.io. with 72 countries and 188 cities being represented. These groups are basically local chapters representing us and making cloud native ubiquitous in their specific area. So hosting vendor neutral meetups, what that means is not selling a product or a service, but focusing on open source and or cloud native projects in a session, a working group, even a study group. There are many creative ways to host a meetup. And then we stress that every chapter is inclusive, and this starts with the organizers themselves. So we even make people take an open source inclusive course, which is an online self-paced course, but you get a badge once you've completed it. And then collaborative. So you're working together, whether it's a city nearby that has a chapter and you're helping promote each other's meetups, or you're giving each other ideas on speakers that are local. It's all about the spirit of open source. And then once you've gauged your community through a CNCG and you're gaining traction with consistent meetups or consistent attendance, then it's probably time to grow into something larger like a KCD. We've had about 89 completed so far with 41 countries and 59 cities represented. But essentially, these are 1 to 2 day like summits that are organized by the community, not CNCF. We are, however, the supporter. So like I said, I am here to provide resources and guidance. And I meet with folks monthly to do that. But yeah, we have seen these in person or virtual like this one, or hybrid all over the globe. And our ambassadors partake in both of these programs I mentioned and much more. But if you're interested in being a CNCF ambassador, then check out this website. Unfortunately, the applications are closed for fall, but we host 2 series of applications each year. And so with those 235 ambassadors, some uphold the standards of excellence and continue on their ambassadorship, and then others step back and they let more people come through that are eager to share and learn with the community. We actually have Matul here, who is an ambassador, and he and Zainul have been great with meeting me regularly on a monthly basis for our KCD check-ins. But I'd like to thank the rest of the organizers as well. They have done a great job at producing this event, and I hope you're enjoying it. And also a thank you to you is a small token of our appreciation. I don't know if you know this, but KubeCon is coming to India. This is the first one of its kind in India. And since it's a neighboring country, I thought it would be great to share a 10% discount code. So go ahead and take a screenshot if you're interested in attending and the dates work for your schedule. But please connect with me if I didn't answer any of your questions, or if there's one lingering question you have. I am available at both of these aliases. And thank you. I hope you enjoy the rest of the event. Bye.
Okay, so yeah, that's been a session from Audra. Although it was not live because it was like she's from US, so there was like the time issue. So that was so nice of her that she just sent this recording of her session. Okay, now what we are going to do is we will have another session. This is from Julia. So let's start with it, and after that we'll have some time. We'll take some break, and after the break we will start the sessions. And those sessions will surely have the quizzes as well. So you have to be sure about it now, starting our main sessions and starting with Julia. So let's start. Let's go with the session.
Today. Hello, everyone. It's a pleasure to be here presenting today. I'm going to talk about a topic I'm passionate about. At the beginning, when I transitioned into tech a few years ago, I was super confused between what cloud computing is, cloud native, all the tools, the terminologies, etc. But during the next 20 minutes, I'll explain what each concept is, and I'll go over some practical tips for you to get started if you want to start learning or even modernizing your applications into cloud native. So I'll help you with all of that. But before I begin, let me present myself. So my name is Julia. I'm a global technologist at Veeam. We do backup, but I'm not going to talk about backup today. And I'm also a CNCF ambassador. I'm an AWS hero in the container area. I'm a Google Women Tech Maker ambassador, a Girl Code ambassador. I organize some meetups in New York, which is where I live. So KCD, same event as this one. We organized it in May, and it was a huge success. I also organize the CNCF meetup in New York and the AWS Community Day in New York. So I'm very involved with the cloud and cloud native community. And that's why I think this talk is perfect, because I've been in your shoes, and also this talk is good for beginners that want to understand better, or even people that have been working with cloud solutions, but they are not sure where they should go next. So let me go backward a little bit. Going back in time, in the beginning, things were very simple. So as you see in the diagram, you had a single piece of software running on a machine, often directly on the user's local system. And whether it was a Linux server or a personal machine, the users were directly interacting with the software. And everything was self-contained, so the software, the operating system, and the user they were tightly coupled. But of course, this setup had limits, as we know. If the machine went down, or if the software required more CPU, more resources, the machine would go down, and everything would go down. So from that, we evolved, and also as the systems became more complex, and the demand increased for applications, we needed more than just one machine. So companies, they started running their software on multiple machines, creating what we called distributed systems. But this also brought new challenges. Could we manage so many systems, and how could we keep them secure and ensure that they would talk to each other effectively? Firewalls and networking tools emerged to manage this complexity and help everyone. But again, scaling these systems across multiple machines introduced management headaches, as each system needed manual oversight. So everything that you needed to manage, you had to do it manually. Is one, which is the cloud. So companies like AWS, Microsoft that has Azure, and Google that has Google Cloud, they offered virtual machines on demand. So no longer you needed to own your own hardware. You could rent it whenever you wanted, just with the click of a button. So the cloud providers, they managed all the physical servers and the availability zones, regions that they offer all these servers, and you could scale up or down based on your needs. So you would just spin up a server, click on a button, a new server would be deployed, and when you didn't need it anymore, you could shut it down. And this was very flexible, but still involved managing the virtual machines, the networking, and the storage manually. You had to do it. So as business grew, they needed something faster and more agile so they could deploy their software. And also because demand was increasing so much, they needed something better. And we weren't still there. So what comes next is the cloud native revolution. Finally, we arrive where we are today. And instead of running full virtual machines, the developers began to adopt containers, which package only the application and its dependencies. So it makes the applications very lightweight and faster to deploy. You don't need an operating system for each application. So these containers that are the new revolution, they work across all the environment. Now, no, the developers don't have the excuse of saying it worked on my machine, because it will work on everyone's machine, and it will work from the developer's laptop to the cloud. And to manage these containers at scale, so imagine you could, deploy a few containers, 10, but companies, they have thousands of containers running applications. That's how a new tool came along called Kubernetes. You've probably heard of it. It's very famous, and it automatically deploys, scales, and manages these containers. So you can see in the graph, Kubernetes manages all the containers. So this is a little bit how cloud native works, but cloud native is not just about containers. There is a lot more around that. It's about designing software using microservices, which are smaller modular components that work together seamlessly. And all of these, we were talking about containers and these microservices, they all work and run in a programmable infrastructure, meaning the servers, the networks, and storage that we have to manage, they can be managed through code, which is what we call infrastructure as code, which all these components are part of the cloud native ecosystem. So I like to say the cloud native building blocks are these 4 ones. Infrastructure as code is another one, but it can be inside DevOps as well. So the 4 cloud native building blocks are DevOps, CI/CD, microservices that we talked about a little bit, and containers. But let's go a little bit more in depth into what each one of them is. So at the core of cloud native is DevOps. And what is DevOps? DevOps is the conjunction of two words, I would say, so dev and ops. And it's the practice of the operations team and the development team, so the engineers, working together, participating together in the entire service lifecycle. So from designing, here you can see the service lifecycle. So from designing through the development process through production support. So with DevOps, the continuous improvement of applications can happen seamlessly. Now, the next building block is CI/CD, and CI is for means continuous integration, and CD means continuous delivery. So there is a pipeline which automates the process of integrating code and deploying applications. So as soon as your developers, they are, creating a new application, building and writing code, they can deploy that automatically through this CI/CD pipeline. And this ensures that updates are frequent, consistent, and less error prone to errors. You can, automatically send that to GitHub if this is, the tool that you use, and it helps, be more faster, deploy code faster. Next, we talked a little bit about microservices, but it's more at the architectural level. So the cloud native applications, they are designed as microservices. Instead of what we used to have, we called monolithic applications, where it was one big block of an application. Now the software is built in smaller independent services that can be developed, deployed, and scaled independently. So if you need even to update one of these services, you don't have to update the whole code. You can just update a small part of it. And each of these services is responsible for a specific function, allowing teams to innovate faster. So all of these concepts, they are tied together, as you can see. And on the diagram in the screen, you can see how it's separated. So there is a service for the users, there is a service for the posts, and now you don't have to deploy one big single block of application. Now, finally, we already mentioned the containers, but these microservices that we were talking about, they are packaged in containers, which provide a consistent runtime environment, and it doesn't matter where they are deployed, in your local machine, on the cloud, it doesn't matter, they will work the same way. And so that's the beauty of containers. They run the applications the same way across different stages of development and production. And now let's talk a little bit about the benefits of being cloud native. So these on the screen are just a few, but first, quicker time to deliver. So with containers and microservices, you have one common language between the development team and the operations team, and you can practice continuous delivery to ship faster. Also, you can modernize present day applications. So shipping the applications in containers reduces the dependencies on underlying infrastructure. And as a result, the previous on-premises applications can be exported to the cloud. Now you can, again, what we just mentioned, you can develop applications quickly, and the cloud native community has a rich technical ecosystem. It's a large community around Kubernetes, around the CNCF. Like I said, I'm a CNCF ambassador, so I'm part of the community. And I think the best thing of working with these tools is being part of the community, because you're not working alone. And all of these tools, most of them are open source, the ones that are part of the CNCF ecosystem. We'll talk about that in the next slide. But this is, the CNCF is really great. And also one of the other benefits is to improve, be faster in innovating, because cloud native brings new technologies, new processes. And again, I think the main idea that we have to keep in mind is that you can go much faster than before. Now, with the cloud native world expanding rapidly, the customers began to feel overwhelmed by all the tools, platforms, and practices available, and they wanted a badge of quality. So they wanted a way to ensure that the tools they were choosing were reliable and future-proof. And they wanted some consistency across the tools that they were using, so be able to piece these tools together and use them in an easy way. And with that came the CNCF, so the Cloud Native Computing Foundation. The need for clarity, trust, and shared standards led the formation to this incredible organization. And now the cloud native world has a unified direction for the cloud native ecosystem. So you can see it was established by the Linux Foundation. There are a lot of several projects that you might know: Kubernetes, Argo CD, Falco, etc., are part of the CNCF, are under the CNCF umbrella. The CNCF hosts several projects. They have conferences, etc. You should definitely check their website. This is their landscape. It's all the CNCF technologies. You should also look landscape.cncf.io. Now, moving forward, let's just clarify the difference between cloud computing and cloud native, because I always messed that up. I thought it was the same thing, but actually cloud computing is the on-demand delivery of infrastructure and services over the internet. through AWS, Azure, Google Cloud, etc. And cloud native, on the other hand, is an approach it's the approach of building and running applications that are specifically designed to take full advantage of these cloud services. So being flexible and scalable. So all the infrastructure and the managed services. So one is the services itself, and the other one is the act of building applications with these cloud services. Now, if you're interested in starting or becoming cloud native, that's what we like to say. You should, first acknowledge that your legacy systems and they aren't inherently, they aren't, sorry, necessarily bad. Because after all, some of our most trusted systems like Linux have evolved from legacy roots. And before you dive into cloud native, you need to ask yourself, what problem are you trying to solve? Because cloud native is not always the right solution for every business. If speed, scalability, and flexibility aren't your top concerns, cloud native might not be the best solution for you because it might not deliver the returns you expect. And again, it's important to remember there is no easy button, like just click, everything will become easier, faster, scalable. Everything takes time, effort, and investment to transition successfully. And one practical way, if you want to become cloud native, if you want to, start somewhere, I would say start with a single workload. Get your feet wet, experiment in a development environment, and learn. Because it's not, straightforward, and you should definitely check the CNCF maturity model, which is a step-by-step journey that lets you gradually incorporate new processes and technologies as your business becomes cloud native. Now, some resources if you want to learn more about what cloud native is, about the technologies. I would tell you first, check out the CNCF website. You could take some certifications from the main cloud providers. The CNCF also has great certifications. Join the Slack, the CNCF Slack, and there are several channels where you can ask questions or just introduce yourself. Myself, I'm a CNCF ambassador, and there are a lot of other ambassadors that create content online. So you can also check that out, check each ambassador, what they do. If you want to learn more about DevOps, there is the 90 days of DevOps repo. So, throughout 90 days, there are challenges and you can learn more about that. And there are books, there are so many things online on the internet. I would say don't get overwhelmed. It's a long journey, but it's a really nice journey. And if you need help, feel free to reach out. I'm always available online. My name again, you saw Julia F. Morgado. And I think I'm running out of time. I had 20 minutes to make you a cloud native expert. And I hope now you understand a little bit better. It's a little bit clearer. And yeah, it was a pleasure presenting today. And I hope you have a great day, great conference. Bye.
Okay, awesome. So we had Audra, we had a session from Julia. So basically, these were recorded sessions because, as I did mention about the time, right? So yeah, now I think we can start our another session. Like we can just start. Like Aditya is already out here, our next speaker. So from now on, we will have quizzes. So you were asking about the quizzes, right? So now we will have quizzes after the sessions. Okay. So Aditya will present the quizzes. Present the session. After that, we will have quizzes. So let me add Aditya to the session. So hey Aditya, can you hear me?
Hey Mitul, thanks
Yeah.
for
Yes.
yeah, yep.
Yes.
I can
Great.
hear you.
Oh, were muted first. Yeah, now it's okay, fine.
Yeah.
Great, awesome. So yeah, it would be awesome. Like, can you please introduce yourself so the folks can know about you?
Sure. Hey everyone, my name is Aditya. I am an infrastructure engineer here at Sysdig. I'm based out of India. If you have heard about Sysdig for the first time, Sysdig is a platform which helps companies to monitor and secure the infrastructure, which is hosted on Kubernetes and containers-based environments. Yeah, that is a short introduction about myself and where I worked at. Yeah,
Hmm. Yeah, awesome. So yeah, if you want, we can now start our sessions. So, okay, let's get started then.
definitely, for sure. Let
Yeah,
me just start by sharing the screen.
sure.
I hope everyone can see the screen. Yeah. Um,
Yeah, I have added that. Yes, now you can see.
Thank you. So let me just get started with the presentation. Yeah. So hey everyone, the topic for today, my topic for today is Platform Engineering 101 with Backstage, where I'll be talking about what is platform engineering, what are its principles, what are the goals that platform engineering aims to solve, and how does Backstage fits in all of this. And along with this, short demo on the platform. So I already introduced a bit about myself, and here's the short agenda for today, which I discussed. Now let's get started on what is platform engineering, why it's even why was this term even present, and how this helps organizations. So my first question is is this just another like a repackaging of DevOps engineering? Like we know that DevOps engineers have been they are like solving more or less the same problems, that is about writing your CI/CD pipelines, fixing your deployments, fixing any issues that you might have in production. So is platform engineering just another repackaging of DevOps? Actually, that is not the case. Platform engineering is about designing and building tool chains and workflows that enable the self-service capabilities, which means that so this is kind of a bookish definition. So if I might simplify it for you, then it would be just that platform engineering helps developers uh, to build their applications and also have the best practices from day one without having to learn about the tools, the tool chain that might be there. So one of the example could be like, I don't want to let's say I'm a new developer and I just want to get started with developing a particular microservice for my organization, and I just don't want to I don't know much about like what's the CI/CD tool of choice that's being used, what is the uh, what's the packaging mechanism, and what artifacts where the artifacts are being published. I don't want to know about that. I just want to build my microservice and want to deploy it to the and I want to deliver a feature uh, for my product. So platform engineering helps you enable that uh, that you what just platform engineering does is you build your tools, like you build your service. We will help you build what's the t- t- uh, later phases of software development that might be there. So coming to back to my example, that would be my so the platform engineering team would help build the CI, write the CI/CD pipelines, not just write, but rather just define that this is the CI/CD pipeline that you need to use. These are some of the testing tools that you need to use. Uh, this is how your Kubernetes manifest should look like, so on and so forth. So when it comes to platform engineering, we have a few principles that we need to stick to. First, you need to define a clear mission and role. So one of the examples could be that we want to build reliable workflows that allow engineers to independently and interact with our setup and self-serve the infrastructure that they need to run their apps and services. Like one of the examples, like if I were to simplify this, It's just about like you want to develop your you want to give self-service capabilities such that devs can create their own testing development infrastructure. They can test out their feature and deliver the feature to the production. So that's one of the example mission that I gave. This could be something similar which you can define for your platform engineering journey. So it should be defined from the get-go. It is also it is also extremely important that you set up a clear role for your platform team, and it shouldn't be all of just another thing like that. You just go and create your dev environments on demand, but it should be just it should be treated as a dedicated product to serve your developers, which are your internal customers. Now, second principle is that you need to treat your platform as a product, meaning that you need to have a product mindset when you are setting out with your platform engineering journey. That is, whatever your platform is, your product is. In this case, it would be your internal developer platform. That would be your product. You treat it as your treat it with a product mindset. That is, you go out and you do user interviews. You seek out what features they would like to see. You iterate upon that. You have an agile life cycle, and you develop a roadmap on what features you would like to develop in your product. So on and so forth. So that is that's the like the complete life cycle that you should follow for your internal developer platform. Next is you should focus on your common problems that is there. So you shouldn't set out to solve unique cases from the get-go. You should first see that what are the common problems that are out there. Say someone is having a difficulty writing the CI/CD pipelines, or someone is having difficulty to create dev environments for testing out their feature. So these could be like some of the common problems that could be there. So you should be focusing on these kind of common problems and solve them first, uh, and make it as part of your first set of features for your IDP. Next is your glue is valuable, which is essentially like whenever if I talk about if we talk about like platform engineering from a CEO's mindset, for example, then they would see it as like a platform engineering. They would see it as a cost. That is, it would be a cost to the organization. It wouldn't be something like like platform engineering teams don't go out and solve your problems in the production. They are just there to glue together the systems, and that's it. So a CEO or someone from finance would think like, why should we fund this platform engineering team in the first place? So the thing is, you need to that is like that first of all that perspective, it's a dangerous one. And second, that this platform engineering that serves as your valuable glue, that where it the job of platform engineers is to like glue together all the important tool chains, all the tool chains and components that you have within your organization. You glue them together and and develop a solution in such manner that this such that the developers, they have a frictionless development, and they can deliver the features faster. So those are like that could be like one of your value propositions that you can share with your manager when you are proposing to set up a platform engineering team. Next is you don't reinvent the wheel. You don't you don't create new solutions to problems which might be solved by someone else. You use whatever that's available out in the market or within the organization. Just try to use them as it is, and glue them together and use within your internal developer platform. So yeah, some commercial solutions, they are more likely they are going to optimize for the generic needs. So whenever there is example like any specific problem that you are trying to solve, then in that case, and which is very specific to your organization, then in that case, it would make sense to invest and develop a solution. But more or less, the focus should be on solving the problems which are which are more common, and it could be like solved quickly. Now, if I were to talk about how this fits in a modern engineering organization, so generally there are four fundamental topologies that are there with any engineering org, which is four types of teams. First is your stream aligned team, enabling team, complicated subsystems team, and platform team. So stream aligned team is your developers. That is, they are assigned to a flow of work. They work on the core business logic, and they solve that particular thing. So if I were to relate an example to this, let's say you have your e-commerce platform, and within there you have like multiple things. Say one is for your machine learning systems, one is for your search schemes, one is for your how the product is displayed. So those are like some of the examples that I gave. That could be like specific work streams for your product, that is your e-commerce domain. Next is on the enabling team. Enabling team, they are like a simple example is your quality engineering or your quality assurance team, your QA team. They help to overcome any obstacles that are there, and they help to detect any missing capabilities. So this could be like I said, that this is a example of a QA team. They help to detect any problems, and they help to you to overcome any obstacles that might be there. Next is on the complicated subsystem schemes. So whenever you have any significant technical expertise that is needed. So coming back to our e-commerce system. So if I want to have uh, say a very let's say I want to develop a completely new machine learning algorithm from scratch, or say I want to develop a new model from scratch, then I would like to form a significant specialist team which would be tackling this complicated problem, and they would be helping to break to solve this particular problem, and where it would help to deliver on that solve that particular problem that's there, which is complicated in nature. Next is last and but not the least, our platform team, which is the job of a platform team is to provide a compelling IDP, internal developer platform, to accelerate delivery for the stream aligned teams. So that is how like the modern engineering org looks like. And platform team, as you have seen, it is involved in the entire life cycle of the stream aligned team, and they help with the whenever with any issues that might be there when it comes to delivering the feature to the production. So yeah, next is, let's talk about what is an internal developer platform. I've been mentioning this for some time, that what is it and what is it about. So platform, internal developer platform, it's the product which is built by the platform engineering team to build golden paths and enable developer self-service. Now, what is a golden path? So for example, like any golden path would be like one example would be your CI/CD pipeline. That is, you build your image, you update the image and all the configurations, and just you are done with it. But let's say you want to have more other features, like for example, I want to have add environment variables, I want to have my services and dependencies, I want to have my RBAC systems, all the refactoring that's there, spinning up any new environment. So all these kind of like these kind of workflows that you would like to have, these are called golden paths, and that is where IDP would help you to achieve this. Internet developer platform consists of many different tools and technologies. They are glued together to have lower cognitive load. So one of the examples is, yeah, let's say you are using Terraform for your infrastructure deployment. You use GitHub Actions for your CI/CD. You use Kubernetes. You use Kubernetes along with Helm for your for deploying and running your applications. and you have multiple, like you use another, like some ingress technology for like deploying your API gateways. So all these tools and technologies that I've just mentioned, so all of these are glued together and they are made available to you as part of the internet developer platform. And as I mentioned, platform engineering treats this IDP as a product, and it is built on user research. It is continuously maintained and it's improved continuously. So what are the core components of an IDP? So I've listed five core components. This could vary with any other organization. They could have uh, even more components compared to this. So these are the core components. First is your application configuration management. This enables you to have your application configuration as code in a dynamic, standardized, and scalable manner. Next is your infrastructure or orchestration. That is all your existing orchestration tools that I just mentioned. For example, Terraform. This could integrate your Terraform could integrate with your IDP, and it could be orchestrated by the Internet Developer Platform to enable continuous delivery. Next is environment management. So with IDPs, developers can self-serve fully provisioned environments on demand, basis on the definitions that are basis on the definitions or standards which are set by the platform engineering team. Next is on deployment management. So whenever deployment automation that you would like to have, it enables teams to move to continuous delivery, and also provides a clear record of each deployment agreement. So as you have noted, you might have noted that the fourth point, it is very similar to what CI/CD, let's say GitHub Actions does, right? So GitHub Actions kind of falls within the IDP, but the IDP kind of helps you to view all these records within a single pane of glass. You don't need to jump around in GitHub's UI to check your deployment records. Next is role-based access control. So whenever I have, let's say, multiple teams, let's say one team for my search, one team for my product history, one team for my machine learning related technology. So all these could be defined as multiple teams, and you can control like what team is can see which components. You can control them via the role-based access control RBAC, which is available within the IDP. It can also help you to limit the production access to a small number of people, while allowing every engineer to create new deployment environments as needed. Now, this is an example of an internet developer platform and how platform engineering ties to here. So if you might see, if I can, I hope you can see my mouse cursor here. So first is about.
Yes, we can. Okay.
Thanks, Mithul. So first is about the product and application teams. They work with the platform interface. That is, it talks about like documentation and search, what templates I want to use for projects and for my environments, what is the UI I want to use, and what is the API and CLI I would like to have. So this product team would be integrated here. They would be responsible for this platform interface and for the capabilities of the platform. So as you can see that it does have many lot of capabilities actually. That is to provision all the infrastructure that is for your databases, your compute network, storage, all your identity access management, your secret management, your artifact scanning, artifact storage, and observability and everything. So these are the kind of capabilities that is there within an internet developer platform, and it is the responsibility of the product, the platform team to maintain this, and it would be the application teams and developers who would be consuming uh, these these capabilities within the IDP. But why do I need a platform engineering? If I already have a DevOps engineer, I already have a DevOps engineer at my organization. He's already seeing all my CI/CD pipelines and everything, and also works for all of the deployment related things. So why do I need this additional team? So like there is a one, if I were to define like take this with a single word, the answer is speed. That is, we work only on the you essentially develop this platform engineering team along with your internet developer platform to increase the productivity. You streamline all the developer environments. You standardize everything. That is what how your code convention should look like, how you should maintain your documentation, how you should write your test, how you should write your particular health chart for your microservice, so on and so forth. So all these things you would like to have a set standard to be followed across the organization. So their platform engineering can help you with that goal. Next is on the improvement of your DevOps metrics. So if I were to talk about DevOps metrics, which is like mean time to recovery, that goes down. That is, if you have all your platform, all your services, all your microservices that are there, if all of it is defined in a single pane of glass, and if there is any incident that is happening, any production incident that is happening, and I would like to know that which that whatever component that has failed, who is the owner and who is responsible for that, then you can direct your questions to that team, and they can help to recover on that particular service faster. So there your mid time to recovery it decreases, and that helps you to recover faster from your incident. Next is change failure rate. That is, whenever you have all these changes, if you're deploying any changes, and if those changes are going to production, and if it is failing due to some or the other reason, then that change failure rate also goes down, and it can help the it can help in the product to have lesser number of failures for your platform, for your application. Next is your deployment frequency increases. So any developer, they would be enabled to deploy more to your to the production environment, and that improves your your feature delivery to, and your you have a faster time to go to the market. Then any lead time, that is, if I were to build any new feature, if I'm set out to build out any new feature which is there in my product, so that I can have a faster development frequency for that, and that decreases my lead time for that particular feature. Now let's talk a bit about Backstage. So Backstage is like one of the tools that can help you to build your internet developer platform. There are many tools that are out there, which both commercial and open source, which can help you to have a platform engineering and to help you with your platform engineering journey. So what is Backstage? Many people have this misconception that Backstage is it's an internet developer portal. It is not. Backstage is it's a framework which helps you build your internet developer portal. So as I mentioned, that internal developer portal. So as the name suggests, internal. So it is internal to your organization, and each and every organization can have a different way of defining what their practices are and how they would like to streamline their developer experience. So it could be different. So Backstage can help you to build that customized experience for your org, and it can help you to streamline your developer experience. So, it unifies all your tooling, services, and documentation. It creates a streamlined development environment. It was created by Spotify Engineering. It started out. It's currently a CNCF incubating project since 2022, and it is built with your React, Express, Docker, Postgres, and Yarn. These are the technologies that Backstage is built with. So what are the benefits of Backstage? So if I were to talk about benefits, then let's take it with the 4 sets of users. So first set of user is your engineering manager, where the EM can maintain the standards and best practices across the organization, and it can help to manage the entire tech ecosystem. Then for your developers, It makes it fast and simple to build software components in a standardized manner, and it provides a central place to manage all your projects and documentation. For the platform engineers, it enables the extensibility and flexibility. You can integrate new tools and services via it, and you can extend the functionality of existing uh, existing tools. And for everyone else, it provides a single consistent experience that it ties all your infrastructure tooling, resources, standards, owners, contributors, everyone is there in the same place. So this is like a simple screen guide that I took from the Backstage website. So you can see that we have all the service definition. This I'll come to it in a bit. You define it in a YAML specification. Then all of these definitions that you define, they are all visible in the Backstage catalog, service catalog. It's all visible here. And then whatever other tools that you might want to integrate, say GitHub Actions, Prometheus, Istio, all these tools, then you can integrate all of them via the plugins that's available in the Backstage marketplace, as well as you can develop your own plugin. So as I mentioned, that everything in Backstage is a plugin. So we have like few core features that are here. One of them I've just not mentioned, that is Kubernetes. I'll come to it. So first we have the software catalog. So all your microservices, data pipelines, libraries, everything, you can have it defined in your in a catalog. Then second is software templates, where you spin up, with which you can like spin up your new projects quickly, as well as standardize all your toolings with the organization's best practices. Tech docs is, as the name suggests, that it's all about like where you maintain your technical documentation, and you can have it as a documentation as a code. And also there is another core feature, which is the uh, Kubernetes plugin, where with which you can have all the visibility of what's the deploy of your deployments, your services, and your components every in of your Kubernetes cluster in the in Backstage. There is also a growing ecosystem of open source plugins for your further customization and functionality. Like you can customize Backstage uh, however you like, and with the use of open source plugins. And there's a growing community, growing ecosystem of that. Let's talk about software catalog. So it maintains your services inventory. So it's a centralized system for keeping the track of all the ownership and metadata of all the software. That is, it could be your services, it could be your websites, it could be your libraries, so on and so forth. So all this catalog, it's built around the metadata YAML files. This is all stored together with your source code. So which is then like harvested, and it is utilized within Backstage. So here's how a software catalog would look like. That is all your components that's in here. That is, it could be, this is an example from the Backstage demo website, which I'll showcase in a bit. So this list all the components that are in here, and which is part of which system, who is the owner of the who is the owner of that component, and what is the life cycle of that particular component. So you can have this list of all the components which are utilized in your application. Then you can have multiple. So here is one component that I've opened, which is like a dice roller component. So as you can see, it has this Kubernetes tab, as well as CI/CD tab, dependencies, and whatnot. So these are like these kind of integration that you can see what Kubernetes cluster it's deployed in, and what's the CI/CD process of it. So you can have all of this integration via the plugins that's mentioned, that's available in the Backstage marketplace. This is one example of the software catalog which is there. So this kind of looks similar to a Kubernetes manifest, which you might where you can say that yeah, that's the case, because it does have these things of what's the links that you want to showcase, what's the type of the component, who is the owner, and what are the API dependencies. So you can define this catalog metadata as part of your microservice, and it can help you to make it visible within the Backstage UI. Now let's talk a bit about software templates. It helps to create golden paths for the new service creation. So as mentioned that software templates, it follows this procedure called scaffolding, which helps you to create all the components inside Backstage. It has the ability, by default it has the ability to load a code skeleton. It will template in some variables, and then it would publish that created generated template to a location. Like for example, if you are using GitHub for your source control, then you use then that new repository that is then published to GitHub. So this is one example that's there. So one example could be like if I have a Spring Boot service, and if I would like to, if I go and select it, and it would show me that what's the uh, uh, like it would ask me some more details to fill in, like what's the name of the service, what's the description, what would be the API endpoint, it would be like, if you will. And that way I can just define that way. When I choose the when I start the template creation process, it would go on, and it would go on, it would run its own Backstage does have its own internal CI process. So it would run that process, and it would build the software template, and it would publish that repository, that newly created template repo, into GitHub. So here's one example of a software template. So here's the, like, as you can see that this is on a scaffolder API version it uses. And you can see that it has this template. It asks for the details, like what parameters it is asking for, like what's the title of this, who is the component, who is the owner, like what's the name of the component, who is the owner of this component. And once these details are filled in, it would start to create the skeleton. It would start to create it would get the skeleton and would render out the template. Now these are the parameters that it accepts, my skeleton accepts. And then once these parameters are validated, it would then publish this to a GitHub repository. And as once this GitHub repo is published, then it would register within the Backstage. It would do the registration also within Backstage as well. So you don't need to, once you create the new component, you don't need to manually register it into Backstage. Coming to tech docs, it is another core feature within Backstage, which is all about like docs like code solution, which helps to build thing like which helps to like whatever your markdown files, your technical documentations are. So they live together with your source code, and and with small configuration, you get a documentation website for your component within Backstage. So this is one example that it can show this Backstage docs as well, like about what like any documentation that I might have for my component. Time for a quick demo. So here's the Backstage demo that I've just opened. So this is accessible to everybody, and you can also like go on and check in that what is this about. So as you can see, as I mentioned, that it has this list of components that's here. So this is again the example from the Spotify's own product, like some of the components that are mentioned. So one of this could be, let's go to maybe artist lookup. So as you can see, it shows me that what are the relations, what are the dependencies this component is on, who is owning this component, and what system it is part of, and what other dependency it might have. So here I've just clicked on artist DB. So it shows me all the details about like what is it about, like any subcomponents that it might have, so on and so forth. It would show about my CI/CD related things also. So this is again enabled via the plugins that's installed here, and that can help you to define about like what's your CI/CD process, about your Swagger API spec that you might have. So if I might show you any component which is having this, so let's go here. So if I want to show the API, okay, not here. Let's take this API. So I have this as API. Okay. Let's say this API spec which is there. So it can show me a
Aditya, can you zoom in a bit? I think, yeah, this screen. Yeah, now it's good. Okay.
thanks. Uh, sure. So as you can see, apologies if the screen wasn't. So here it shows about what's the GraphQL definition for that I have, and this shows me about what's the component, what's the relations that it is having with, and all the other details. So here I can see that what's the this detail all about. So let's say if I open any open API spec here and I go to definition. So yeah, this is what I wanted to show. So here you can see that this is a simple like pet store open API spec which is there. So here you get a Swagger UI as well. So if you are having the relevant permissions, then you can do the with the Swagger API call. You can test out the call here itself, and you can see all the details in here itself. That what is it about? So here also you can have a with your open API spec defined properly. Basis on that, you can define you can have this Swagger UI for yourself, and you can test out your API specification. Yeah, and that's the catalog part. Now, if I were to show the documentation side, so let's say I want to show this backstage, this documentation, for example. So here I have this backstage documentation itself, where I can just see that what is it about, like what are the definitions. Like if I want to navigate within this documentation, then it allows me to do this via this via the TechDocs plugin. So this helps me to navigate the documentation here itself without having to step out into any other UI. Say maybe like something like Confluence or something else. Yeah, so that is more or less about the demo part. That concludes the demo. And now I open the floor to any Q&As that might be there.
Yeah, sure. So let's hope for the questions. Let's folks, you can ask your questions if you have any, right? Now's the time. So yeah, I think we have a question which is, okay, what inspired you to explore platform engineering and backstage?
So platform engineering, I would say it started off as a kind of a necessity within my org, where it was where there was a requirement to explore all the internet developer platform that might be there, and also how to enable like self-service and smoothen out the process for the developers faster. So all these kind of questions they like inspired me to explore platform engineering and also leverage backstage for my requirement. So yeah, hope that answers your question.
Yeah, I got it. Like starting with the like issues, I guess, like how it solves the problems and so on, and then you explode it, and I think then the backstage. Okay.
Yes.
Another thing is, okay, how does backstage simplify the management of Kubernetes resources and applications?
So backstage is all about like it shows you in it's kind of a UI for the developers, if I were to oversimplify it. But so any sort of like Kubernetes applications that you might be there, that might be there in your in your environment. So you can visualize that how it is deployed, what is the status of that service, and you can like essentially own that particular service in that particular environment without having to ever log in into the Kubernetes cluster. And that way you can you can ask the your site reliability team to maybe like check out the service within this particular environment to see if there are any issues, or maybe like check it out yourself if your organization allows to, maybe has that policy to you build it, you own it, kind of policy. That is uh, yeah. So hope that answers your question. So Backstage
Mhm.
essentially provides the UI for your component for your particular service, and then it's up to you how do you would like to address any issues that might be there. That is, yeah.
Okay. Another question, that is, how do you see platform engineering evolving in the future, and what role will Backstage play in this evolution?
So, platform engineering is one of the main goals that it helps to satisfy is like simplify the developer onboarding. I think we have a session down the line as well. That so whenever any new developer would like to joins the organization and they would like to
Mhm.
learn quickly about what's the component and what are the applications that he's working on, and he would like to learn more about it, so he can just self-explore the all the details and all the components within Backstage, and they once they are good with all the things that they need, they can start developing on that service quickly. So that's one requirement which is fulfilled by platform engineering. But later I see that it helps to even self simplify, like enable more developer self service for the organization. That is, it helps to developers just let them do their job, and we don't interfere in their things like working with the, like for example, any security patches that they might need to do, or anything like how to maybe like improve the how the application is deployed, so on and so forth. So there could be like many such things that the developer needs to do, and all of this we can just remove them off that all these things off their plate, and they can just focus on the development and delivery of the feature. So yeah, I see
Mhm.
platform engineering evolving into these two directions, and it can help to fulfill these two goals.
Okay. Another question from Abu side. What are the prerequisites of learning platform engineering? Any suggestions for like undergrad first year student? So yeah.
Yeah. So if I were to take mention about like the first year students, I would say that platform engineering is, it's too niche of a platform, like too niche of a discipline to get into right now. Platform engineering
Mhm.
is all about like you get a few years or years of experience uh,
Mhm.
in maybe like things like software development. And software development is, I would say, is the ideal path to get into platform engineering, because when you are developing software, then only you will realize that there are many such or even if you are a data scientist also, you would be involved in some part of your development career that you are deploying any service to the production environment, or you are monitoring any service, or you are part of any incident response process where you learn more about the service and its dependencies. So once you are, you get a few experience there, then you would have a chance to to learn more about platform engineering, and then you have a good opportunity to learn more about it. So hands-on experience is necessary.
Yeah.
Yeah.
Obviously. Okay, so I think with that we will wrap. This is the last question we'll take. Like, does system administrator can start his career in platform engineer who has primary knowledge in DevOps?
Yes, I would say that system administrator already has, they have already seen the things on the operation side of things, that um, how the system is deployed, what are the configurations of the system, what
Mhm.
requirements does the application have to run successfully. So all these, they already have this knowledge from the operation side. Now to get into the platform engineering, again, it requires a bit of, as you have seen that the Backstage, it's not like a simple like a one person effort. It requires a bit of platform, like it requires a small platform engineering team to build it and maintain it. And to build a platform to build this kind of like internet developer platform, you need to have some experience with soft, software development, say maybe like working with React, working with Node.js and Docker. And so all the software development side of things also like comes into play. So I would suggest that if you are coming from a sysadmin background or even a operations background, then I would suggest to have a bit of knowledge on the how to uh, on building JavaScript related applications, because when you are building your Kubernetes, your Backstage plugin, that is the place that you will be working, that you will be involved most, and that's when you will need that knowledge of software engineering there to become a platform engineer.
Yeah, I think we have actually more questions, but I do think we should take more questions because yeah, we have some questions, some sessions coming up, right? So yeah, thank you so much, Aditya, for an awesome time, and yeah, so yeah, thank you so much, and with that, I think we can end our session, right?
Thank you so much. And yeah, feel free to join me on like I have my LinkedIn also as well.
Yeah, feel
If
free
I
to
might,
just share here. I guess I can share that. Okay, wait.
I'm just
Okay,
switching to that slide itself.
okay,
So
yeah, great.
yeah, it's in here. So you can connect me here on LinkedIn, and I am feel free to ask away any questions that you might have for platform engineering or DevOps.
Okay.
I'm happy to answer.
Yeah. Yes, awesome. So yeah, let me. Okay, thank you so much, Aditya. Then, and I hope to see you soon. Okay,
Thank you so much, Mithul.
bye.
Bye.
Okay, so yeah, that was it. But now the interesting factor, the quiz. Okay, let's start the quiz. Okay, now how are we going to start the quiz? Okay, so if you have actually learned about learned what he has mentioned, so I think we have like 14 minutes. Start our next session. Within that, we will just end our quiz. So the winner of the quiz will get a prize, and we'll mail that. Okay, so there will be like this session has a quiz, the next session has a quiz, and after that we have another session that has a quiz as well. So let me share my screen, and the rules are simple. So let me just first of all let me tell you the rules. But yeah, the rules are simple. Let me, how can I do that? Okay, wait. Background is okay. Great. Okay. So let me share the rules. The rules are, I will share the Mentimeter link, or you can just go to the Mentimeter first of all. Then, when I'm going to share the screen, you will see QR code. You can do that, or I will share the code as well. You can see that. You can just join in. I will share you the questions here in the screen. So you have to use your mobile or other device to actually answer the questions. The problem is, like in general, the questions are not. If I'm not wrong, you can't see the questions in your phone, but you can see your question in the screen, I guess. So let me share my screen. So, and with that, we will just, let me share my screen first of all. Okay, let me go here. And I will share my screen and I will share the code here, okay? Let's start the quiz for the first quiz and for the first winners. Okay, let me share. Okay, great, share. Okay, so I think it'll take some time. Okay, please let me know like if you can see the screen. And what I'm going to do is you can just scan this QR code. Okay, let me do one thing. I need to share the code, right? Okay, let me stop the sharing and share the code first. Then I can share the screen again. Apologies for that. Okay, show the instruction bar. I think now it should work. Okay, great. Let me share the screen again. Share. Okay, great. Okay, so now you will see the code. Okay, the code is 5242 and then 5845. Just join in. Let me write it down the instruction again for the quiz. Where is okay, go to mentimeter.com, just Google it here. then you'll just add the code. Code should be 52425845, right? 52425845. Great. So I have just shared in the comment section. You can just use that, and using the link and the code, you can just join in. Okay, I can see 4 folks have joined in, so we have like I'm waiting for you. We'll wait for like 2 more minutes, then we can start. Okay, so let me check how many. Okay, let's wait for that. Please let me know if you face any issues. I can see 6 folks have joined in, so yeah, let's wait for 2 more minutes. Okay, 6, still 6. Okay. Okay. Anyone facing? Okay, it's 8 now. Great. Great. 10. Great. That's good. I think it will be competitive. Okay. Let's wait for 2 minutes. I think this is other. So let me stop. So we haven't started because the Azan is there. So we'll start once it ends. Okay. Okay, so great. I think we're ready, right? So let's start with the first question. And are we ready? Just do let me know, because yeah, I think folks have take a pause because of the Azan, right? Please do let me know in the comment section. Like, yeah, we're ready. Then we will start the quiz. Can we see? I can't see any comment on that. Please do. Okay, great. Yes, I think folks are ready. Let's start. Okay. So here goes our first question. Okay, enter. I think you can see that. Okay, wait. Yeah. In the modern engineering org, which team is formed when you need significant? Okay, what? That's team, aligned team, enabling team, or complicated subsystems team, platform team. I think there is one thing that's missing, but yeah, we had no option. Choose that. Okay, one person answered it right. That is complicated subsystem. Okay, I think I should take some time because there is like only 15 seconds and you have to answer it fast. Okay, we'll move to the next question. Yeah, great. So let's move to the next question. Okay, I think. Okay, I first of all let me get you guys ready. 16 players, 17. Okay, then I will enter 18 players. Great. Let me enter the question. Okay, great. I think that should be easy for you guys. Answer first. Okay. How long should a platform engineer team exist? Okay, that's a typical question. Till the end of a work stream, sorry, very short duration, only in the middle of a sprint, or should exist for a few days. That's a question you can't, like, I don't think you can just search in the Gemini app or something. Okay, till the end of the work stream. So many of you are so confident of it. Okay, great. Let's see. That's great. Let me move to the next one. Let's wait for you guys to enter. 17 players ready, 18 players ready. I think we can start. Enter. Answer first to get more points. So yeah, that matters. Which of the following is not a core component of an internal developer platform? They did mention about it. Application configuration management, deployment management, infrastructure orchestration, attribute-based access control is not a core component. There were some component, and here is not a core component. So you have to be sure about it. Okay, 10 people were. Okay, that's great. You had very good attention to the session. That's really great to see. Okay, great. Let's wait for the fourth question. After that, we'll have our last question for this quiz. Okay, let's start. Enter. Answer first to get more points. How is the software catalog built in Backstage? Okay, manual entry, sorry, CI/CD pipeline, YAML manifest, or Terraform integration. Okay, let's see. $15. Great. YAML manifests. Great. Okay, that's good. And now we will have our last one, and we hope after that we will have a winner. Obviously, the winner will get a prize. So yeah, great. Enter. Answer first to get more for. So whoever the winner will be, we will be asking through. You have to just mail. Wait, which feature is used for maintaining documentation like code in Backstage? Okay, great. Software catalog, take docs, software templates, Kubernetes integration. So it is take docs. Great. I think apart from the first question, every time we had a winner, like maybe the first question we had one winner. Now let's go for the leaderboard and let's see who wins. Okay, great. Okay. Okay, that's Mahinur. That's great. We have our winner, and you can. Okay, so feel free to just mail us. Okay, please raise your hand in the comment section. Okay, that yeah, you're here. So now also I'm sharing our mail. So feel free to just we've got your account, I guess. So that's great. And I think Joinal is out there. So what you can do is you can just contact him, and we can just give him the prize. Okay, so we'll just contact with you. No worries with that, and you can just share our mail. Okay, through our accounts. You know, the KCD Chattogram. You will just share in the page. You can just share that. Yeah, this is our account, So this is your account and so on, and then we'll ship our price there. Okay, so that's it. Now we will start our another session, and the speaker is out here. So let me stop the stream, that one, and after that session. Okay, hello, Apu. Can you hear me?
Yeah.
Okay, great. So I think we should take a bit of time because the Azan is still there. That might be interrupting. So let's wait for 1 or 2 minutes, or you just let me know once that ends. Okay. Uh, yeah. Okay, let me share this banner as well. Okay, great. Okay, so we can start, right?
Yeah.
Yes, great. Okay, so let's start our session. So the sessions, our topic is from monolith to microservices, how Envoy transforms service communication. So let's start with it. So Apu, when you are ready, just feel free to share your screen. I think you can just present from that one, like plus present, I guess. That's the option. Yeah, I think, yeah, that's great. You've shared your screen. Great. Please do let me know when I need to share the screen or share the slide. Then I will add it. Okay, I think that's good, right? Okay.
ওকে সো মিতুল আমার স্ক্রিন দেখা যাচ্ছে এখন আমার স্লাইডটা
হ্যাঁ হ্যাঁ দেখা যাচ্ছে আপু, আপনি শুরু করতে পারেন।
আচ্ছা সো হ্যালো এভরিওয়ান আমি আসলে আজকে যে আমাদের টপিকটা সেটা হচ্ছে মনোলিথ থেকে মাইক্রো সার্ভিসে আমরা কেন যাব এবং কিভাবে আসলে আমাদের সার্ভিস কমিউনিকেশনটা ট্রান্সফর্ম করে অনভয় সেটা নিয়ে আজকে আমরা আসলে আলোচনা করব ফার্স্টে আমি আমার সম্পর্কে বলি আমি হচ্ছে ফারজানা রহমান আমার 7+ ইয়ার্স এক্সপিরিয়েন্স প্রিভিয়াসলি আমি আসলে ট্র্যাডিশনাল ওয়েব ডেভেলপমেন্টে কাজ করতাম এখন আমি আসলে ক্লাউড নিয়ে কাজ করি মেইনলি আমি আসলে AWS এর সার্ভারলেস টেকনোলজি নিয়ে কাজ করি এছাড়াও আমি আসলে ক্লাউডের অন্যান্য যেমন CNCF এর আজকে যে সেশনটা অনভয় এটা আমার খুবই একটা ইন্টারেস্টিং একটা টপিক আমার এটা খুব পছন্দ হয়েছিল তাই জন্য আমি আসলে এবং যেহেতু মেইনলি অবজারভেবিলিটিটা আমাদের খুবই ইম্পর্টেন্ট সো আমি আসলে ক্লাউড নিয়ে কাজ করি আর এখন আমি আসলে ফ্রিল্যান্সিং শুরু করছি সো এখন আমি লেভেল 1 ফ্রিল্যান্সার ফাইবারে এছাড়া আমার AWS এর সার্টিফিকেশন আছে তাছাড়া আমি AWS এর কমিউনিটি বিল্ডার এবং এই ইয়ারে আসলে AWS অথরাইজড ইনস্ট্রাক্টর হিসাবে আমি হচ্ছে কনসিডার হয়েছি আর তাছাড়া আমার আসলে মানুষের সাথে নলেজ শেয়ার করতে ভালো লাগে আর আমার আম্মুর অ্যাবসেন্সে আমার গাছের পরিচর্যা করতে ভালো লাগে এটা আসলে আমার সম্পর্কে আর আজকে আমাদের এই যে সেশনটা সেই সেশন শুরু হওয়ার আগে আমি আসলে জানতে চাই আপনারা এখানে কয়জন ডেভেলপার আছেন এবং আপনাদের প্রজেক্টে কয়টা আসলে মাইক্রো সার্ভিস ইউজ করতেছেন এরকম হইতে পারে যে আপনারা আসলে মনোলিথ অ্যাপ্লিকেশন ইউজ করেন তো সেক্ষেত্রে কে আসলে কয়টা সার্ভিস তাদের প্রজেক্টে ইউজ করতেছেন mostly আমরা মাইক্রোসার্ভিস 1 থেকে 5টা সার্ভিস হয়তো ইউজ করা হয়। তো সমস্যা নেই, আসলে আমরা যে আমাদের জানাই লাগবে যে আসলে মাইক্রোসার্ভিসে কি হয়। আমরা আসলে ফুল সেশনটাতেই মনলিথ কেন আমরা মাইক্রোসার্ভিসে যাই এবং মাইক্রোসার্ভিস নিয়ে আমরা আসলে কি প্রবলেম ফেস করি বা অবজারভেবিলিটি কিভাবে এনশিওর হয় মাইক্রোসার্ভিসে, আমরা ফুল সেশনটাতে সেটা জানবো। সো আজকে আমাদের ফার্স্ট এজেন্ডা হচ্ছে আমরা আসলে ডিসকাস করব মনোলিথ অ্যাপ্লিকেশনটা কি এবং মনোলিথ থেকে কেন আসলে আমাদের মাইক্রোসার্ভিসের যাওয়ার প্ল্যান করতে হয়। আর okay, sorry, actually today my session was in Bangla, that's why actually I'm talking to Bangla, but I will try to take this session in English. So first my agenda is I want to talk about why actually we want to go monolith to microservice. Then when actually we go for microservices, there are some challenges we face, so I will talk about it. Then actually why actually Envoy, how Envoy actually solve the problems in microservices, then some building blocks of Envoy, and if there is a request in Envoy, then how actually it works. And then I will show some simple demo of Envoy. And then actually there will be a quiz. So we'll take these things. So first of all, so I want to talk about why actually, what is the monolith application. In monolith application, actually everyone, every code is in the same code application. So here actually I'm giving some authentication, user, product inventory, order, and payment. So these features are in the my monolith application. It is a e-commerce site. So when actually in my e-commerce site, actually when we are working on it, so we have a small team. So maybe we have 5 or 10 people, engineers working on it. So but when actually our business is growing, we have the business critically arises, like previously in auth application, maybe we have the email and password. And when actually our business growing, maybe we need the Gmail authentication or Facebook authentication. So we use these things recently. So if our user wants these things, so we have to integrate these things into our authentication system. So see, our business is growing. So and the features are increasing. So previously there were 5 different features. Now maybe our user can ask us that we should have add the shipping system. We may need a notification system. Should have add some recommendation system, review system. So see, we need our features. The features are growing. So and when actually our user growing too much, maybe some previously per second we have 5 hit in per second, but 10 or increases to 1000 per second, 10,000 per second. So in this case, actually it is very important to ensure the faster response of your application. Otherwise you lose your customer. So and like say the inventory, product inventory. So when actually we have the e-commerce system, the feature we use the most, that is the inventory, product inventory. We search the product, we just see many products, and maybe little of them we actually order. We add our cart, then order it. So but the main our main goal was to search the products. So we need to frequently add our products. We update it. Maybe some are stocks out. So we have to work on these things. So in this case, if we just want to scale my application in our monolithic application, then we have to scale the whole application. But maybe I don't need the whole application scalability. I need only the product inventory, because in this area, actually, I have got more user, more hit. So I need that particular scalable. But as in monolith application, all these things in a single application, single code. So I have to scale up the whole thing. So even if I want to work in a particular one section, like the inventory section or maybe the authentication system, I have to test it. But when actually I deploy it, I have to deploy the whole system. So it also takes the time to increase the deployment time. And if I just want to scale up my monolithic application, it requires more resources. So it actually cost our operational cost, increases our operational cost. And also it is risky if some engineers are working in the authentication feature and some engineers working in maybe in the inventory. So I just want to deploy my inventory section, but I have done a maybe the full working is not done for the authentication system. In that time, actually, there is a risk that I can deploy a partial work. So that is also a risky thing. So, these type of problems we face in monolithic application when actually our business grows. And so to solve those problems, actually the microservice concept arises. And the microservice thing is like we just break the small pieces, the monolithic application, we just break into some small pieces, like previously authentication, user, then a product inventory, all this in a single thing. But now actually auth is a single service, product inventory is a single service, and everything is a single service. So when actually I'm working in a single service, I just can independently deploy this service. So I don't need to scale the whole system. I can scale up the particular service, like the inventory service. So even when actually I'm just deploy my inventory service, actually it does not impact any other services like user or authentication or order. So I can easily deploy without any impacting other things. And also when actually our engineers are growing from like 5 to 100, I can allocate them for the specific services. They do not have to uh, memorize or they do not have to focus on all the business logic in an application when actually your application grows much. So your engineers can focus on a particular service. So this is the thing actually why actually we need to go from monolith to microservices. So but when actually we come to microservices, we actually face some challenges. Like in microservices, we know that there can have multiple languages. Like maybe my front end written in React, maybe my backend have multiple languages. Like some of my code is written in Python. Maybe authentication system is written in Python, but my payment system, it is written in Go. So when actually I am doing these things for different languages, how actually I do my stats, how do I my login, how, how I just do my tracing, what actually happens in my services, how actually I can see those things. Previously, my monolithic application, I can see all the log into a single place. But when actually my services are different, so how actually I know that what actually happens in which services. So this is a very big challenge. And then actually previously we just used the HTTP protocol, but now we just use HTTP2. Main HTTP2 means previously it actually one hit, then again then the second hit arise, it is HTTP1. But when actually we work in HTTP2, that means we can handle a concurrent hit. Then remote procedure call, databases. Sometimes we need the caching. So see, there are a lot of protocols we have to handle in our microservices or in our monolithic. But the challenge in microservice is when actually we have to all these things, all these protocols for different languages, we have to use is what I want to scale up my application for or scale up my a particular service. So I have to use my load balancer. So if I just use a black box load balancer like AWS ELB, then I don't AWS handles all these things for me, and they also have the log, and but I have to search for S3 by default. Log go to S3 S3 access object service. So uh, I just can search services there, but I cannot see all those things in a single area, in a single place, that how actually happens. And as AWS did all these things for me, actually I do not know what is happening in load balancer end. Is if any problem occurs, is it my application end, or is it in load balancing end, or is it in networking end? How actually I know these things. So there is a chance that lack of observability means some service engineers may have like authentication system. There is stress tracing login, but when actually maybe in payment system or maybe in the inventory system, there is not that the tracing is properly integrated. So here actually we as a distributed system engineer, we always our manager always told us that we have to use the best practices, but we should use the retry, circuit breaking, rate limiting. Circuit breaking means when actually any instance or any service down, we should uh, uh, dynamically detect those things uh, and handle that things. So rate limiting means when actually I am maybe I just my application can handle 1000 hit per second, but there is can have 2000 hit per second. What actually we should do? We can limit our rate. We can set a limit that in that our application will not overwhelmed if someone running any script. So I know that it is when actually my hit actually arises, it is my main customers, not any bot things hitting my application. So but there is a chance that these observability things or these best practices things are partially implemented because of these different languages. So when actually you have to use this circuit breaking, you have to code all those things for all those services. And the main challenge is you have multiple languages. So, and another in case of the security things, uh, we mainly what actually we did, that we just authenticate in our age. But when actually if we just need to authenticate our services, intercommunication things, then there is a chance that we do not authenticate it, or authorize anything in microservices. So there is some security issues, how actually we authenticate our systems when actually internal service communications happens. So the thing comes everywhere, that the different languages cause us many things, all these problems is. And we actually do not, it is very difficult for us that debug the where is the latency issues. Maybe my one request can go through the 5 services, so 3 of them works fine, but fourth one causes the latency. But if I do not have the all these things in a proper tracing system, then I could not understand that where the latency actually occurs, or where the failures occurs. So if I don't know it, then I never can solve it, and my it it take too long time that to solve any problems. So all these things actually it lift engineer Matt Klein, actually when he joined the lift from Twitter, he actually faces these things in their microservices things. So he actually uh, he actually think that there should have a system where actually network should be transparent. And if what actually your application doing, what actually your network doing, you need to identify that things, and you have to fix it within a limited time. So Envoy is the created for this purpose. And well, actually, I'm saying that Envoy is originally built in at Lyft, but there are some other organizations when actually Envoy is created after 6 months. Google and IBM and other companies, big companies, actually interested in these things, and because the observability things is very important for all of those companies, big companies, because they have all very distributed applications and they face these problems. So that's why actually Envoy is going to open source, and all of them actually uh, contributed in these things. Envoy is written in C++, and the main core feature is Envoy is the dynamic service discovery. The dynamic service discovery means uh, service discovery is like you have the 5 services. Okay, so now you have another service. So how do your other services know that there is some other new services, and how they actually communicate? So previously there are some service registry, you have to add those things there and you have to restart these things. But in Envoy, you do not need to restart anything. You have dynamically, like it is actually working through an API. That's why dynamically a service can understand that there is a new service and I need to talk to them. So there is the these things, dynamic discovery, service discovery, and then advanced load balancing. So there is some tool like Nginx, then HA proxy. All those things are the load balancing things, but Envoy is particularly created for the distributed system, and the advanced load balancing algorithm is used here. So and the main thing is the dynamic system is creates these things from different from other available services. So, and another thing is the circuit breaking and fault tolerance. Envoy ensures that Envoy can detect the any faulty services, and if any, actually it can check the health of your services, and if any service down, it automatically detect and remove it, and then actually it passes its request to another healthy services. So it can Envoy can do these things very well, and the main uh, important feature in Envoy is the observability. It gives a detailed log uh, data, metrics, stats, tracing. I will actually show a simple demo for the observability, how many requests I have, how many error I have got. I can see in a single place for different languages. It doesn't matter that which language my service is written. I can see the same format for my all these logs, and the extensibility is there. After some time, actually, we'll talk about the building blocks of Envoy. So we can see that there is some filter chain. Mainly in filter chain, actually, we can do some customized things, like we can add our authentication system, or we can add some rate limiting. If I want some custom things by my own, I can also do that. So there is there is the extensibility in Envoy. So another thing is Envoy actually maintain the uh, um, fault tolerance things in such a way that uh, we can just easily handle our any problem, any we don't need actually write all those things for our every services. We just need in and just Envoy. We can configure the Envoy, and Envoy did all these things for us. So in our building blocks things, I want to share. So here actually when actually a request hit into in Envoy, we can see that maybe an user from hit the client app, and the client app was which a request actually talk with my Envoy. So I need a IP address and a port. So this is called the handle multiple listener at a time. And here in this section, actually Envoy can handle filter chain. There can have multiple filters in this area, and after processing that those uh, after processing those actually filtering, then actually Envoy decide where actually it uh, send its request, in which cluster. Cluster means the group of endpoints. Like your payment system have multiple endpoint, for endpoint A, endpoint B, endpoint C for payment. Because if one endpoint down, then Envoy automatically can detect those things, and it can send it request to Envoy, maybe the endpoint B. So this is the logical service that the group of endpoint is called the cluster. And when actually this backend service is called the upstream and the client app is called the downstream. So actually we see this terminology in Envoy everywhere, that mainly this is the building blocks for Envoy. And it actually happens from request first go through the listener, and the listener go through some filter mechanism, and then after calculating those things, it choose a route, and there from that route it actually select a cluster and is for going to a service. So this is the Envoy building blocks. And so when actually any request comes to Envoy, uh, actually mainly there is some other terminology you see in Envoy, like service mesh. What is actually service mesh? Service mesh is, you can see here that uh, here you can see service one. So, this is the 4 different services. So these 4 different services, when actually they talk, they actually, it is called the service mesh. How actually they are talking, this is the mesh. So in Bangla, the mesh means jal. So services jal. So আমরা যখন আসলে সার্ভিস গুলো, when actually we are working in uh, these services communication, so this is called the service mesh. And Envoy is particularly designed for this service mesh, because see here actually when the service A is know the Envoy, it actually does not know any other services, any other things. It just know the Envoy and local Envoy. So local Envoy actually talk to the another local Envoy of another service, and that's how they actually handle their load balancing things for per maybe this service actually handled by this Envoy, and this service handled by this Envoy. So no one actually connect depend on another Envoy. So it can easily handled through per Envoy. So the ingress and the egress. Ingress means the when actually connection comes from outside of Envoy, and when actually connection goes from Envoy to outside of any service, it is called the egress. So besides these things, actually there are some other configuration thing, like you can use a single Envoy for load balancing. Maybe you have a small application. There is no need that if you have to use Envoy, there should have so many microservices. There is nothing like that. If you have the small microservices applications, you can use Envoy in there. So maybe you don't need that much. Every service don't need the single Envoy. So you can use a single Envoy for all those services load balancing thing. There is another, we can mix these things, mixed configuration, like we just use Envoy as a egress, and we just can Envoy as ingress or as egress. So here actually mainly when we can use the authentication, rate limiting, we can use these things here. And when actually and between our services, we don't need any Envoy or anything, but we can just communicate, we can just tracing things, but or logging things. We can see those things through this Envoy. So there can be a configuration like this. So we actually there we maximum time we use this type of configuration, like maybe this service need Envoy particularly, but this service B don't need it, or service B is a legacy system. Okay, so maybe I do not can attach Envoy in that system, but I want my legacy system in my tracing in my Envoy logging system, but because I want to know where actually my problem occurs. So if I just my legacy system is not added into this system, I do not know where actually the problem occurs. So I have to add it, but maybe this single service do not the dedicated Envoy for it. So there can be a configuration like this. And another configuration may be the multiple layers. I can use multiple layer because one layer may be used for authentication, one layer may be used for load balancing, one layer may be used for another circuit breaking. So it is not important to one Envoy one Envoy have to do all those things. Maybe I can filter out one after another and get back the request from a in a single layer, depending on the filtering things. So I can use different type of configuration, different type of uh, filtering mechanism in Envoy. So it is the live request when actually a request comes on Envoy. So how we can configure those things? There are some processes like this. So
Apo, I think we are running out of time because it's like 8:57. Are you
okay.
going to run a demo?
Yes, just a short demo, just 1 or 2 minutes
Uh,
it will take.
okay, so if that goes, okay, we can do that. Okay, sure.
Okay. Uh, so when actually I'm just creating, I will upload it into Git so I can share those things. So here actually I'm showing, okay, so I am just using my endpoint service. I am just using two services here. So here actually I'm using the I want to handle some error, and I want to handle some the right approach 200 things. So first when actually I hit my endpoint, so I can see the uh, it shows the errors, and after third time I can see uh, the successful status. So now in my logging status, so Envoy shared these things that I have just created 5 upstream, and among them I have just got 2 successful requests, and the 3 are the 500 requests. So I can see those things from Envoy in a single place. So that's it for today. So uh, if there is any question.
Okay. So let's see. We'll take. I think we will take very less question, like maybe one or two. Okay. Then we will go for the quiz. Okay, and
Yeah.
then we'll start our next session. Okay. Let's see if we have any questions or so within that. folks, we have you any questions? Do you have any questions? You can just ask here. Okay, so okay, there is a question related to AWS, I guess, community builder. As an AWS community builder, how do you see Envoy integrating with AWS services in a microservices architecture?
Okay, so AWS has the app mesh. Mainly, app mesh is on top of Envoy. So you can use app mesh. Actually, mainly it is connected with the Envoy. It is used Envoy.
Okay, I hope that answers your question, Journal. So yeah, I think we'll take one more questions, and then if we have any, then we'll go for the quiz questions. Okay. Okay. Let's see if you have any questions. Feel free to write it down in the comment section. And let's see. Okay. Okay, we have another questions. I think we will end with this. Okay, for developers or operations engineers looking to specialize in microservices and tools like Envoy, what learning path would you recommend?
So it actually depends. What actually you want to. The developers need separate things, and operational DevOps engineers need, have different path. So it depends on which path actually you are working. So there are multiple. It is not a simple thing, simple answer that I can see that can tell that Envoy is for observability. It is not for the full path of learning the development things. So particular particular um, designation need the particular path. So it is I cannot say in a single line that this you need to that these services only. So cloud native application, you have different services. If you want to use some other cloud things, there are some other things. So DevOps things you have to can use the Istio. Istio is also used for on top of Envoy. You can use the Prometheus things. You can visualize those things with Prometheus. So there are different services.
Okay, I hope that answers your question, Journal, as well. So yeah, I think we can wrap up the session, Apu, if you like. Yeah, if you're there.
Yeah,
So
thank
yeah,
you.
thank you so much, Apu, for your session, and yeah, I hope to see you in the next in any next meetups, I guess. Okay. Okay. Thank you
Yeah,
so much, Apu.
thank you.
So yeah, with that I will
All
end
the
the
best.
question session. Yeah. Okay, great. So we have another sessions coming up, but the thing is, uh, our speakers are still in the backstage. They are here, but one thing I have to do. First of all, I have to run a quiz, a quick quiz, 5 minutes. I think we have a gift, like a gift, depending on the quiz, and after that we have another session that also has a quiz. So yeah, let's start the quiz, and let me share my screen, and that will be the quiz. Okay, let me go here. I think we will take less time this time. Let's see. Uh, from monolith to microservices. Let me share my screen. This time we won't have any leaderboards, I guess. Let me present, share screen, microservices. Sure. Okay. Please do let me know if you can see the. Okay. Okay, wait. I think before, prior to that, let me just stop it. Stop sharing. I shall add a leaderboard. Just let me add that, and we'll start with that. Okay, add a leaderboard. Okay, great. Now we can see the leaderboard as well. Let's start presenting and stream the share. Wait, where are we? It's great. Please do let me know if you can see the screen. Okay. can you scan the code? If not, I have to mention manually. Can you please let me know if you can see the screen or not? Please do let me know. And what I'm going to do here, just within that, let me add this one so that you can see. Great. The code for this quiz is 59684666. Okay, please do just join the Mentimeter with this, which is the code is 5968 and 4666. Okay, let's see when it pops up. Okay, okay, I think folks can join right now. You are joining, that's good. Let's wait for a bit moment. uh, okay, great, you can see people joining in. Have 12. Let's wait for a few more. 4, we can see 4. See, let's wait for 1 minute and I'll just quickly run the quizzes, and because we will start our next session very fast. Okay, 59684666. Okay, let's start within a while. We have just 1 more minute, then we'll start. Okay, you can see 5 more people. So the next session is on onboarding doesn't have to suck, elevating developer onboarding through platform engineering. So previously we have learned about platform engineering a bit, right? Where we had one session on platform engineering 101, right? So now if you had more questions, I think that will be answered by our speakers. But hold on, just I think we will take 5 more minutes just to wrap up this quiz, and then we'll just start the session, right? I can see my speakers in the backstage. I think I will take a few more minutes just from you, just to end this one. Okay. I think we start. We can see folks have joined. I think that should be enough for us. Let's start. Okay. Okay. Next slide. We had, let's see, no problem. Okay. I can see a lot of people. 13 players ready. Let's start with the question. If you have attended the quiz session, you will see which of the following is the best describe. This describes the key characteristics of transitioning from a monolith architecture to microservices. Yeah, this is a big question. You have centralization of data storage, decreased network complexity, decouple of services, and reduction in overall code base size. Okay. Okay, 7 of you were right. That's good. Great. Then the next question. I think you are ready. Let's go. Let's enter the question, and that's is, let's see, Envoy is best described as in what? Okay, a database management system for microservices, if high performance proxy and services mesh, a containerization platform for deploying some microservices, a monitoring and logging solution for distributed system. 10. You were done within 10 minutes earlier. 6 were right. That's great. Even I had to take a pause, actually, checking the options, and you are taking less time. That's interesting, right? Okay, let's go for the next question, which is, answer first. Which of the following is not a core building block of Envoy? Not. Okay, you have to keep in mind. Listeners, filters, cluster, containers. You have to keep in mind it's not. Okay, let's see. 10. That's, I think that's the number, right? Yeah, everyone has voted. Great. uh, okay, it should be containers, so still we have winners. I think that should be the last question. And 13, I think 12. Let's enter. Okay, 13 players. Let's enter. Let's see what's the question is. In the context of Envoy, what typically happens first when a request is received? Load balancing, listener processing, routing, protocol conversion. Okay, 10 seconds. 8, 7, 6, 5, 4, Oh, okay. Much prior to that. Okay, if you're onboarded. Okay. Every time with answers. And that was correct as well. Listener processing. Okay, I think with that we'll see the leaderboard. Okay. Can't see. Okay, I think it's Fatima, and congratulations on winning this quiz. So what you can do is you can just I'll share our KCD Chattogram page link. You just have to message us with your YouTube handle, I guess. Then we will just do that. Please do first of all let us know in the comment section, like yes, you're doing that. You are the Fatima. Then we will just process that. So let's stop this sharing, and we can. I hope journal you will just check that out, right? Kindly check this out. Like, kindly let us know in the comment section, like who is the winner, and kindly I'm sharing the page link. And as soon as I do share the link, I will start the next session out here. Okay, let me share this one here. Here's our page link. Great. Okay. So I think we have our winner. So she'll be contacted. Okay. Now let's actually add our speakers for the next session, and let's add them here to the stage. So hello, Adriana and Anna. Can you hear me?
Yes.
Awesome. Great. So okay, we can start our session, right? But first of all, I would like you guys can start with introducing yourself, I guess. Then we can start our session, right? So yeah, Adriana, you're muted. Okay.
Sorry. Our intros are part of the presentation, so we have that covered.
Okay. Okay. Great.
Yeah.
Then I think we can start our session.
Cool.
Okay. Let me add this presentation. Okay. Great.
Perfect. All right. Hey everyone, welcome to Onboarding Doesn't Have to Suck. We're super excited to be presenting to you today. Before we get started, allow us to introduce ourselves. My name is Adriana Vilela, and I am I've been doing computer things for about 20 years, longer if you count me learning BASIC at age 10. So I've been doing this for a while. I'm a CNCF ambassador, second year HashiCorp ambassador, blogger, and podcaster. I have a podcast that I do with my daughter called Geeking Out. By day, I am a senior staff developer advocate in the observability space, spending a chunk of my time as a maintainer of the OTel end user SIG. And by night, I climb walls at my local climbing gym, and I also love capybaras.
And hey, y'all, my name's Ana Margarita Medina. I have the pleasure of working alongside Adriana, also as a senior staff developer advocate, as well as a second-time CNCF ambassador. I'm part of the GC for CNCF's Captain Project, contribute to the Kubernetes release team, also a member of the Open Telemetry End User SIG, and I sit on the Code of Conduct Committee for Kubernetes. I've been in tech for almost 15 years, and I've been focusing on cloud infrastructure and reliability for the last 7 years. When I'm not doing computer things, you can find me cooking Latin food, watercoloring, or messing around with makeup looks. So let's get this talk started. But prior to getting the talk started, we have a little fun skit prepared for you. So hopefully that will get a way to get started the talk and set up the scene for today.
Mm-hmm.
Hello, Adriana. What's happening? Welcome to your new job.
Oh, thank you so much, Anna. Happy to be here.
You should have received your new laptop by now. After I explain HR policies and procedures, you will go ahead and join Bob, Milton, and Peter in a Zoom call for tech onboarding over the next 2 days. There, you and your classmates will sit and install the company's blessed tools on your devices. It's mandatory attendance. If you can be there by 9 a.m., that would be great.
Wait, we're going to be installing things manually?
Yeah, of course. We have always done it this way. Do you have a problem with it?
Well, that'll take days, and I kind of have this really nice automation set up with Ansible to install all my tools.
Yeah. That's nice. But you can't do that here. Go ahead and keep that for your personal laptop. We have our allowed set of tools and you can't deviate from that because we need to stick with corporate compliance rules. If this scenario is familiar to you at all, you're not alone. The fact of the matter is that onboarding can be challenging and stressful. After all, you're in a new job with new people, new policies, and new procedures. You also have to deal with the new tech stack and tooling. This often comes with a high learning curve as you're trying to navigate a new environment. But you couple that with the fact that many organizations don't have their act together and don't have a streamlined onboarding experience. This results in a very, very time consuming process. One of the challenges that we have when setting up new developer machine is software installation. Many organizations just provide new employees with machines that have a base image. This contains a common set of software of tools that is used by everyone in the company, regardless of the role that they're in. This software includes and is not limited to this list, starting out with something like a browser, something like Chrome, an email client, something like Outlook, some productivity tools like Microsoft Word, Excel, and PowerPoint. Of course, we can't forget our collaboration software like Slack or Teams, or the video conferencing software like Zoom. And lastly, we have our security software like a VPN. This means that developers must then take some time to install development tools on their own. And then, depending on the type of organization that they work at, that installation experience can be very different. It can be one of the following.
The vault. So here, developers are allowed to install software only if it's from an approved list. And this is usually managed by a security team, and approvals for software might take a really, really long time. Now, this type of thing is common in organizations that maintain high levels of security and compliance because they're dealing with extremely sensitive data. So you might see this at a financial institution or a healthcare institution.
Then we have the red tape tango, where developers are allowed to install software from an approved list, but they can go through this whitelisting process to add more software to that approved list. This might not be the vault, but due to the processes and policies, approvals for software might actually take a while. And this is common in organizations that maintain high security, compliance standards, but they do have some wiggle room. This includes things like SaaS companies or consulting companies.
And then finally, we wrap things up with the wild, wild west. And this is where we can have a free-for-all. Basically, developers can install whatever they want on their machines. Usually that means that the organization lacks processes or guides on how to get started. And we see this type of thing in small fledgling organizations where security isn't a concern, at least not yet. So for example, in small startups. So all that said, what exactly goes into a developer environment? Now, the list that we're going to show you is by no means exhaustive, but it should give you a pretty good idea of the type of tooling that developers want and need. So, of course, we start with our language-specific software development kits or SDKs, such as the ones that we might use for Python, Go, and Java. After all, you need to compile or interpret your code. You need to be able to package it up, etc. Now, of course, we can't forget our integrated development environments or IDEs so that you can write your code along with the applicable plugins that you love and rely on. And of course, as a developer, you have to be able to actually install these plugins on your favorite IDE. Now, as developers, we also love our command line. So having a terminal and a default shell is important, along with the ability for developers to install and configure their favorite shell. And who can forget Git for source control management, along with various command line interfaces or CLIs, depending on what your team does. Now, this may include things such as kubectl or perhaps a CLI for the cloud provider used at your organization, whether it's AWS, G Cloud, or Azure. We also need some virtual environment tools such as Docker and VirtualBox, and supporting tools required by your team such as Postman and Homebrew. Now, with all the stuff that you have to install on your machine, wouldn't it be nice to have a one-click install of all of this stuff from day one? And this is where platform engineering can help. But first, let's define a few terms. Now, we realize that there are many, many different interpretations and definitions of platform engineering, and our favorite one defines platform engineering as the next step in the evolution of DevOps. So let's start at the beginning with our baseline definition. So DevOps gives us the fundamental principles of collaboration, codifying all the things, automating all the things, and rapid feedback loops. Then site reliability engineering, or SRE, applies those DevOps principles with the focus on customer impact and reliability. And so going to platform engineering, we see that as an extension of SRE. Now, while SRE is focused on external customers, platform engineering takes things a step further and also focuses on internal customers, i.e. the developer. And developer experience, or DevX, is but one aspect of platform engineering, and that happens to be what we'll be exploring today. But what is DevX? DevX is about how developers feel, think, and value what they do. But why does it matter?
Well, it's not just according to us that DevX really matters. According to DevX in Action, a study of its tangible impacts, a study by Dr. Nicole Forsgren and others, published on ACMQ, developers who find their tools and work processes intuitive and easy to use feel that they're 50% more innovative compared to those with opaque or hard to understand processes. Unintuitive tools and processes can be both a time sink and a source of frustration. In either case, a severe hindrance to individuals and teams' creativity. This means that DevX matters and it impacts developer productivity and satisfaction. Furthermore, the report highlights that there's a difference between simply writing code and writing code in an environment that is optimized for writing code. Environments that are optimized for writing code are efficient, effective, and conducive to well-being, and they rely on the right mix of tools and practices and processes and social structures. If you want to take a look at the study, you can scan the QR code that's shown here, or we have it all the way at the end as well. So, what should we keep in mind when building out an onboarding experience for your developers? Well, you want to make sure to ask yourself these questions. Whether it's in the security or flexibility, or that you need to care about dependency management or time to value, but you're just asking these questions to understand the type of onboarding experience that you want to bring to your developers. The thing is, the platform engineering is great because you actually don't have to choose one column over the other. So, you might be wondering, how is it that I can get this done? Well, before we answer that question, we have to look at two more terms that we need to define. Let's take a look at two developer type of environment setups. On one hand, we can use self-contained environments. This is where the developer machine has just the base tooling only, nothing else installed, and developer tools are accessed via a containerized or virtualized environment. This runs either locally or on the cloud, or a combination of both, something like a cloud-hosted developer container and a local IDE. Examples of this include things like GitHub Codespaces or Vagrant.
On the other hand, you can install all of your tools locally. So this is where your developer tools are installed and accessed on a local machine. Now, this means that it requires more local compute and storage compared to running a self-contained dev environment in the cloud, where your workstation is basically just a terminal in that case. Here is where a configuration management tool such as Ansible can be used to configure and install developer tools locally. Now, you might be wondering, okay, what tools do we use to accomplish this? So here's a list of the tools that can help us with these kinds of setups, and they're listed in alphabetical order. So we have Ansible, Backstage, DevPod, GitHub Codespaces, Cradix, Port, and Vagrant. Now, this chart here gives you a basic overview of the capabilities of each tool. And while some of the tools do the same things, other tools can actually complement each other to help improve developer onboarding experience. So let's take a look at what two potential platform engineering onboarding flows might look like.
The first example shows the onboarding flow for a self-contained developer environment. In this case, is going to be leveraging GitHub Codespaces. With GitHub Codespaces, the platform engineering is responsible for creating the Codespaces configurations, and environments can be easily spun up as well as brought down. Since the whole environment is remote, you don't need to worry about having the right amount of processing power or storage space and developer tooling running on your machine. The trade off here is that you probably need to manage different code spaces for different repos or even different branches. The flow works as follows. The developer arrives on onboarding day very excited about their workday. The developer then kicks off the onboarding process by going to a designated wiki, which takes them to a GitHub repo. From there, they're able to bootstrap a virtual environment running on the cloud hosted by GitHub. This environment contains all of the tools and configurations needed to start adding value to the team. Once this environment is created, they're able to work on their first PR. This is hopefully done on the first day of work.
Our second example is an example of a local install onboarding workflow. So remember, as I mentioned earlier, that unlike in the self-contained onboarding workflow, the developer does all of the work on their own developer machine. So making sure that you have that good amount of storage and compute power is essential. But it also means that you have to have all of the tools that you need at your disposal in the same place. So you don't need to rely on a network connection to be able to access those tools. Now, here we're making use of a developer portal. Now, examples of developer portal tools include Backstage, which is actually an open source CNCF tool with an optional paid SaaS offering, and Port, which is a paid SaaS offering. Developer portal tool would access GitHub Actions to orchestrate the onboarding, or it can be any other type of orchestration tool that tickles your fancy, like Jenkins, for example, and then Ansible to install and configure tooling onto the developer workstation. Again, pick your favorite configuration management other than Ansible. Could be Puppet or Chef, for example. So in this flow, the developer will kick off the onboarding process from a developer portal. The developer portal tool then triggers a GitHub action. The GitHub action in turn kicks off an Ansible playbook. And this Ansible playbook is responsible for installing and configuring on the developer machine in much the same way that you would do on a production server. So in this case, the production server is your developer machine. The playbook also sets up the appropriate permissions and access to various systems and services that the developer will need to access during their time on that team. Now, at this point, the developer also has the option to kick off workflows to install additional corporate sanctioned developer tools via the same developer portal. So basically, it follows the exact same steps that we covered earlier for the base install. So there you have it. Now, before we wrap up, we wanted to leave you with some tips for building a better onboarding experience for developers. First off, you need to balance the ease of installation of software with security and compliance constraints. Is your organization a Vault, Red Tape Tango, or Wild Wild West type of org? And do you want to provide your developers with a self-contained or local dev environment setup?
The next tip is that we need to remember that DevX is never done. There's always going to be room for improvement. So make sure to check in with your newly hired developers to get feedback on their recent onboarding experience while it's still fresh on their mind. But similarly, check in with all developers a couple of times per year to get their thoughts on developer experience in their teams. And finally, keep that feedback running by running a developer experience surveys 1 or 2 times a year. And you have to remember that you don't want to work in isolation. DevX is a team sport. You first need feedback from InfoSec to make sure that you are addressing those security requirements that they have, but you also need to work with developers to understand what types of tools they need and why they need them. You also want to make sure to talk to other platform engineers outside of your organization to see if you can pick up any interesting tips, tricks, or best practices.
And finally, don't forget the humans. We are huge fans of the buddy system for onboarding. So the buddy system is the system whereby you pair one seasoned employee with a new hire to be the go-to source when they come on board. You want to also ensure that you create and foster relationships between your new hires and leadership, along with some teammates in other key departments like sales, marketing, and product. And chances are when you're onboarding for a new organization, you're not all onboarding in the same area. So you're not necessarily onboarding with all tech folks. You're probably onboarding with some sales folks, from some marketing folks. So this is a great opportunity to make friends with those folks, to really get some insights into how other parts of the organizations work. And finally, have a place, whether it's a Slack channel or a group in Teams, where new hires can talk to one another, meet each other, and ask questions. So before we sign off, we wanted to leave you with some useful resources and some shameless self-promotions. First of all, if you like reading, we have a blog post version of this talk. And as Anna mentioned earlier, we do have a link to that study that she was talking about on developer experience. We have a couple of cool technical links as well. So first of all, if you want to see what it's like to use an Ansible playbook to install stuff on a local machine, I actually have an Ansible playbook for installing developer tooling on my personal machine every time I get a new laptop. And it's come really handy, and I've open sourced the work. It actually came in handy after I got my my latest personal MacBook, where I promptly, a month after getting it, spilled like a half liter of water on the keyboard and basically fried the machine. So after I came back from repair, I used my Ansible playbook to reinstall everything. Also, there's a really cool repo called HashiCube, and it's basically, it spins up an entire self-contained environment provisioned using Vagrant, and it runs on Docker. And basically, it installs all of the HashiStack tools, including HashiCorp Nomad, Console, Vault, all in a Docker container, so that you can use this as a single integrated self-contained development environment for playing around with the Hashi tools. And this is, again, an open source project. It's very cool. As I mentioned, I have a podcast that I run with my daughter called Geeking Out, and I've had some awesome guests on, such as Kelsey Hightower, Hazel Weekly, and Charity Majors. And Anna has also been a guest on my podcast. And Anna and I used to have a podcast together. It ran for 2 lovely seasons, and it was awesome, and we miss it dearly. And we also had some really awesome guests on our podcast, including Alex Hidalgo and Liz Fong Jones. So definitely check it out.
And in case you're wondering, all the images in this deck were generated by AI, because while we can't draw, we are great prompt engineers. So thank you to our evil AI overload, Bing AI, powered by DALL-E 3, for these images.
Yeah.
And thank you so much, everyone, for attending our talk. Signing off with peace, love, and code.
Awesome. Yeah, thank you so much for your submission. I think we can take 1 or 2 questions if you have. Okay, so let's open the comment section for the questions. Okay, folks, you can ask your questions out here. And after that, obviously, we'll have a quiz, small quiz, right? Okay, let's see. I think we have a question, and the question is, what are the common challenges in developer onboarding that platform engineering aims to address? Let me just hide it out. I hope so. Yeah.
I can start with it. I
Yeah,
think
sure.
one of the main ones is that you want to ensure that your entire company has similar tooling. And that means like standardization, and you want to do that for many reasons. You want to do that for the fact of collaboration, like everyone having access to the same language and being able to collaborate more easily. But you want to do that from a security standpoint as well. You get a chance to standardize the versions of software that folks are in, so you can keep an easier, like a closer look at vulnerabilities that are going on with every single version. And all of this really just allows for like that ability for engineers to really start providing value to the team. You're also codifying it, so you have ways to keep things up to date, but also really give it to engineers and have them get started as soon as possible. And things kind of get started, similar to how like Adriana talks about her Ansible playbook. You can get a new laptop, run that on your first day, and within a few hours, you'll be able to get access to all of your tooling after logging in and really start contributing.
Yeah, it's really about getting that consistency across the board so that you're not like, oh my God, what was that configuration that I used again?
Okay. Another question from him, and that is, how can platform engineering streamline the onboarding process for new developers?
I think just by having it codified, because you've defined it as code, like you are basically saying this is how we do it, right? You're kind of saving developers from themselves by putting guardrails on the onboarding process, and by basically you're adopting those principles of DevOps.
And this results into things being done a lot quicker. So it can be seen as like setting up a DigitalOcean, AWS, Kubernetes cluster. By this being codified, everything is kind of being done, and this is going to be like installing like the basis of it, things that need to go on top of it. And this means that it's going to take a lot less time than someone having to go through manual steps, copying from a tutorial, copying from a wiki page. And it also leaves for less room for error. So you're spending a lot less time on debugging and having to go back and forth between another team of like, I installed this, what's my next step? And of course, this also means that you're not sitting in a classroom like we explained in that video, where you're like spending 2 days installing 10 pieces of software. So you're really making it about like, we want to get you up to speed to do the things that you're here to do.
Mm-hmm. So yeah, I hope that answers his question as well. So we will wrap up this session, I guess, now, because yeah, the our other speakers have joined in. So yeah, thank you so much, Adriana and Anna, for your time, and really enjoyed your session. And I hope folks will learn a lot of things, and they will contact through the socials as well. Okay.
Thank you for having
Okay.
us.
Thank you.
Thank you, and bye.
Bye.
Okay. So yeah, that was it from Anna and Adriana. But we have a quiz to take. Okay, so we'll take the quiz, and this quiz again as prize with it. So let's start with it, and after that we have 2 more sessions today to end on KCD. So let's start sharing. Let me share my screen. First of all, okay. So we have 4 questions this time. Let me share the screen with you. Okay, great. So I think that should be great for us. Let me present it, okay, so that you can see. So here is the code. So here you can see the code is 331444309. So you just go here. I think you had a question, Journal, but we couldn't answer. Let me share the code again. Journal code. That should. Okay, so let's wait 1 or 2 more minutes. Okay. So after that, we have another session after the quiz, and that quiz is from the speakers are Ronit Banerjee and Ritik Roy. Okay, so it's basically about the community, building a cloud native community from scratch. So they will share the story about the CNCG Hoogly. The thing is, CNCG, we have started with Audra, right? Audra was mentioning about KCD and CNCG. So we are here in this KCD. So today again we are going to learn about CNCG, how it works. Basically, CNCG is first of all, to organize the KCD, we have to start with CNCG, right? Okay, let me start the quiz. So here goes. I think we'll start as soon as I see the pairs popping up. Let's see, it's like 7 pairs right now. Should we wait a bit or not? Let's start. Let me wait for maybe 30 seconds more, then we can start. Okay, so I hope you guys are ready to start the quiz. Multimeter, that's great. Okay, let's start. Okay, here goes the first question from the session which we had. And so first, according to Anna and Adriana Stock, which is not a type developer onboarding experience. Okay, so they were like Wild Wild West, Red Tap Tango, the Vault, the Box. So we had few options, and let's see, everyone has voted. Okay, the box. Okay, it was not by type of thing. Great to see that. Let's go for the second question, 7, 8. Let's enter this one. Answer first to get more points. And what is platform engineering? Great. So this question's platform engineering session was taken. That we had 2 sessions on platform engineering today. So we will learn about it, an extension of SRE with the added focus on internal customers, the replacement of SRE, cloud native environments only, or another term for ops. 6. Okay, 6. So the folks were they knew about it. That's great to see. Okay, let's go for the third one. Okay, let's see. That's a question. We have 4 questions, so this should be the third one. Which of these is not a type of platform engineering tool? The tools are mentioned, so here it is: Ansible, Vagrant, Backstage, or OpenTelemetry. Let's see. Who wins? Okay, OpenTelemetry. That's impressive. Every time you were very, I think, very conscious about sessions. We have 7 players right now. Let's end this one with the last one. Let's go. Answer first to get more points. Which one of these is not an advantage of making DevX important in your organization? Increased developer innovation, increased developer productivity, increased GitHub stars, increased developer satisfaction. I think that should be easy, and it depends now who answers first. Everyone has voted, and increase GitHub stars. That's great. I have seen like all of the answers. I guess most of the answers which were correct. We had a lot of people who could answer correctly. So let's see who on this one. Abu Said, Sanjit. Okay, let's see. Abu Said. Okay, congratulations. And kindly let us know in the comment section like you won. And also, I'm going to share the page link again. Just go there and share your details. Okay. Okay. So yeah, thank you so much. Let me stop sharing here. Yeah, Abu Said, I can see you. Okay, Journal, I think you can share the page link, and so that Abu Said can may actually answer DM us, right? So I can see our another like our speakers for the next session, right? So let me add both of them to the stage. It is Ritik and Ronit Banerjee. Hello, Ritik and Ronit. Can you hear me?
Yeah, we can.
Yep, loud and clear.
Yeah, awesome. So yeah, glad to see you guys. I've been like in touch, like I've been actually following Ritik for a while, right? We've been in touch in I think LinkedIn DM, but we didn't have any opportunity to meet, right? But I think that's if online meetup we can consider. Yeah. Thank you
Yep.
so much for accepting the session. And now let's start with the KC our session, right?
Yep.
You can start with like
We
introducing yourself, and then we can start, I guess.
sure. Let me share my screen.
Sure.
And yeah. Yeah.
Yes, I can see that.
So
Yes.
so hi everyone. I'm Ritik, and today we are talking about something very interesting and close to us. That is building a CNCG from scratch. So we'll get down in what is CNCG and what is cloud native Hoogly a bit later. But to get started, who are we? So we are the organizers of Cloud Native Hoogly. It's obvious, right? Because we are talking about Cloud Native Hoogly right now. And also, we are CNCF ambassadors. So that is common between us, but we have a lot more things to share. So this is me. This is from this January when I was below the Northern Lights, and I work as a platform advocate at Loft Labs. I'm a Google Venkat scholar as well. Like that was a scholarship which I got 2 years back. It is like top 10 people in the whole India who got a scholarship from Google. And I got a couple of certifications as well, like CK, KCNM, and all those. And if you want to connect with me, this is my socials. It's Ritik here across everything. So if you want to connect with me on Twitter, LinkedIn, or somewhere else, that's my socials. Giving the stage to Ronit. So,
Yep. Thanks, Ritik. Thanks, Mithil. So, hello, guys. This is Ronan. And yeah, as he said, that we have something common. That is, we are both CNCF ambassadors. We are both the organizers of Cloud Native Weekly. And I'm like obviously into DevOps engineering. And obviously, yeah, the one I forgot to mention. This picture is from Golden Gate Bridge, San Francisco. I was there a week ago. So yeah, and like got a few certifications like KCNA. Have been Google Summer of Code mentor for DBP, the organization which is based out of Germany. And if you want to follow more about my work, about my social presence, then definitely give it a shot. Ronit Billens across everything apart from LinkedIn. You can get it by Ronit Banerjee. So that's pretty much about myself. And yeah, so initially would love to discuss like, do you actually know about CNCG? What is CNCG? So if anyone is there to answer the private chat, then they're mostly welcome. But if not, then we can proceed with the full form. That is actually Cloud Native Computing Groups, right? That's it, if I'm not wrong. Yeah, it is. So yay. Cloud native computing groups fostering local cloud native communities. So the thing is that CNCF is a huge organization, right? So it's not possible for CNCF to reach every corner of the world individually. So what they do is that they provide us support from their side in form of chapters, and like enthusiasts like us and people who are already in the ecosystem are actually creating these chapters, driving this type of community initiatives, so that people, like-minded people, students, and also some working professionals can come at a place and discuss about cloud native stuff, right? And we actually support events, meetups, initiatives aligned with the cloud native technologies, and we also collaborate with them. And the thing is that we are just not limited to cloud native. We also talk about more things that are actually relevant on the like nowadays tech space. That's it. Yeah. Uh, yeah. So can you get that to the next slide, Ritik?
so
Yeah.
now what
So
is Cloud
yeah.
Native and CNCF?
Mhm.
So this is a KCD, and you might have heard about a lot about CNCF, a lot about Cloud Native, but we just wanted to touch a bit on that as well, so that you have more context as we go forward. So, so whenever you heard Cloud Native, it's not always associated with CNCF. Cloud Native is a scale level way by which you create microservice containers, and where you can have interoperability between different clouds. So whenever you are building something, you don't need to depend on certain cloud providers. And the benefit is a couple of them. First is ecosystem. So whenever you're not depending on certain specific providers or certain specific things, you can have a diverse ecosystem. Whatever you're building on a certain cloud, you can migrate that to another cloud. And whatever you are building can be used by another people as well, another organizations. So this was not a very common thing previously before the cloud native things came in. So it was like whenever you are using a certain VM or something like that, it was a lot of lock-ins. But when CNCF came up and when Kubernetes came in, so it created a platform over the cloud, like an operating system for the cloud, where you can have tools, your software, and your developers build something that can be migrated to different clouds and can be served from different clouds. So that was the story of cloud native. But CNCF comes into the picture to make sure everyone involved in the cloud is non-competitive and working towards the similar goal of providing better experience for all the developers and providing governance so that everyone is working towards a positive change in the community. So CNC provides a lot of things. Like it's a big non-profit organization under the Linux Foundation. So it provides a lot of things, like it makes sure the technical oversight is there. So technologies are moving in a way which is helpful for the community and not just a specific company. It is bringing people closer. Right now, we are situated in India and we are giving a talk in a virtual conference in Bangladesh. So that is the thing. So it is bringing people close. And lastly, the most important thing which is revolving around is the community. So everyone is here for the community, and CNCF knows that. So CNCF supports meetups, events like KCD, and very bigger events like Cube Day and KubeCon India. So there are big KubeCons coming, one in November in Salt Lake City, and one in December in New Delhi in India, and one went by in Paris. So there are a lot of events being covered across the globe. The goal is a simple goal, so more people come together and share their learnings, share how they are coming together, share what they are doing, so more companies can benefit through that. More companies can save cost and more companies can provide value both to the consumers and the users. So where is Hooghly? Like, so if we see, this is a global map. You can see India, you can see Bangladesh beside it. Hooghly is a small place beside Kolkata, and our chapter is situated there. And in the last year, a question was there: why is a community required, or when is a community required? Before we build everything, which we will talk about today. So a community is required for a lot of reasons, and here are a couple of them. So when you want to share knowledge and when you want to benefit through the knowledge of other speakers and other attendees, when you are doing something, a community comes in a good picture to help you do that. But apart from that, it also serves as a networking opportunity here. So you can network with people who are doing things and also network with talent. So if I'm working somewhere and I need interns, the community can be a good place to find people who are actually interested in. I don't need to go through LinkedIn, Google, and all those to such people who are interested in. If people are joining in, coming in, so I know they are interested in. Also, it acts as a source for me to give back to the people by sharing my knowledge and all the things. Last is support system. So when we are in university or when we are in school, we see a lot of flashy things happening. We see a lot of new technologies coming in. We see a lot of new technologies growing fast. But the problem is, how can we be a part of it? Like there is so much things happening, but it's so problematic because we don't know what to do. So communities come as a good place where we can find mentors who will help us both in personal and professional growth. They have walked the path which we want to walk, so they have that experience both in technical and non-technical POV, where they can instruct us on what places to focus on, as well as what things we should learn or what things should implement. Like for example, one of the best advice I got was to focus on a bit far-sightedness. So if you're earning some money doing some specific jobs, that might be a good approach. But if you focus on the future, focus on the skills you can gain, that can give you better returns in the future. So those advice and those networking opportunities come when you are in a similar place, and this is where community comes in. But one of the most important things, when what people forget when focusing on building a community, is something called shared struggles. So imagine you are in a company and you have a shared problem, a problem to find a job or problem to find ways to learn more. It will connect you more than a problem where you're just doing to do things. Like a problem where you are trying to find a solution to all of your situation is a better way to build a community than in comparison to just building a community. For us, we wanted to share this story and help people because there was nothing cloud native in Kolkata back then or the bigger region. So that struggle me and Ronald understood, and we wanted to share and bring people together. And that is helpful because when you are building and bringing people together through a shared struggle POV, then people want to stick together because they want to solve the struggle. It's not just people are coming in, getting some value, getting some swags, and going back. They have the struggle which is bigger than swags, values, and all those things. So they come together, and there is a unity which helps you to bring more people together and focus on long term relationships. For in our local community, there were a lot of speakers who came in to share about their learnings and everything. And a lot of students are still in contact with them because they understand the importance of going through that path. And lastly, when you are having a shared struggle, you can see everyone is growing together when you are solving the struggle. It is not like the organizers are getting more benefits or like that. So there is no like those problems. It's like everyone is learning something new. Everyone is growing together, and everyone is trying to solve the problem. But they want more understanding of cloud native, and they want more flexibility and more resilience towards learning new things, which are very hard. Cloud native is a hard thing. It comes after you have understood cloud, understood some tools fundamentals, have some experience in development, because you need to build, you need to deploy the things through cloud native. Building is one part, deploying is another part. So the cloud native part is very helpful over there. But again, you need people suffering through that same struggles to bring them together. So that is one of the most important learnings that I have. Whenever you are building a community, shared struggle is a key factor. But we will talk about more struggles later on. So coming back to how everything started in China. So Roland can talk more about it.
Yep. Yeah. It's a very interesting story. So the thing is that me and Ritik met in India, but he never remembers that thing. Okay. And surprisingly, like I do, because definitely it's Ritik. So the thing is that we went to China for KubeCon. We both were on scholarship, DanCon scholarship, and after reaching China, like it was our first time like seeing each other, knowing that yeah, this is Ronit and this is Ritik. Okay, so and that very moment we connected on this idea, very idea of creating this particular chapter, and like before we met, I already put up like there's some form kind of thing where we need to request for a chapter. So before going to KubeCon, I already applied for this chapter, and I asked Ritik if he wants to hop in because he has created a lot of impact in the cloud native ecosystem throughout Kolkata and India as well. So he instantly connected with my like problem statement, and we were good to go basically. And yeah, that's how actually cloud native Fugli happened. Starting from China, it's like chutney chop to China. That's how we call it. So yeah, next slide please. So yeah, after that we had a couple of events. We had some in-person events. We had some online events. We had a small like DevOps bootcamp as well, where we were talking about networking. We were talking about Linux, talking about Kubernetes basics, Docker basics, etc., etc. So it was also something which we came up with, and also we were planning to extend it like some deep dives on those particular topics, maybe some other cloud native tools as well. So we have like planned it but haven't executed it yet. So these are on like the process, the pipeline. And the one we are actually having right now is a hackathon, which we are conducting, offline hackathon. So this is something new. I don't think that any cloud native chapter has ever done it, which is pretty new concept for some cloud native chapter. But yeah, let's try it out. We are pretty much sure that we will do it well, but fingers crossed. Yeah. So the next thing that is actually very, very important, that is volunteers. Without volunteers, we are nothing. So me and Ritik, it's very difficult for us to manage everything, right? So we have very, very talented volunteers on the team. And it's not just the volunteers, they are actually like a family right now. They know every single problems, how like we deal with it, what are the like sponsorship challenges, how we will manage the large scale offline events, how we will manage the food, logistics, blah blah blah, many many things. Okay, and they actually help us a lot with those things. Kudos to them, a huge shout out to them that they exist. Otherwise, it wouldn't have been possible. Budgeting is primarily a key factor for any cloud native chapter, and we are lucky to have both the organizers as CNCF ambassadors, so we can have some monthly reimbursements through which we fund our events, and also we have a couple of sponsors if we need. And we already talked about the team, and yeah, so core teams and the volunteers, yeah, that's it. Next, please. Yeah. So struggle. Basically, the first thing is that we were new. So, for example, I came from a cloud native background, but I never had a chance to like create a community by myself. So this was kind of something new. I was working on with different communities. I worked in different communities, but I have never led one. So this was fairly new, and I think most of the people who like belong to college or are students somehow, they know how college communities work. They are like a bit of closed environment thing. And for like cloud native chapters like this, it's a bit open. Like uh it's too much liberty for the first timers. Like, okay, you can do anything you want. So that's what I actually enjoyed. So yeah, but with great power comes great responsibility. So did we. And we had very limited exposure initially. So we had to create that brand value. The marketing team, the designing team did a wonderful job in that. Like any design, any memes you see under cloud native Google's hood, like give it a thumbs up because they have done a wonderful job. And cloud native chapter was a very very new concept to our local community. Like it was a bit difficult for them to grasp. Like it, they were like, what is cloud native? What is the difference between cloud and cloud native? Is cloud and cloud native the same thing? Then why native? Like there were many, many, many doubts, okay, around this particular story. But finally, we could crack it down, and the people are much, much aware. We are like almost having 1K members in our Discord server. Officially, the channel has like the community page has more than 700 members. Like it's a huge feat for us in in under a year. So we are really proud of our team, and Ritik as well. Like he has done a wonderful job. I helped him with whatever I could have. So yeah, and the best thing about our community is that we had people from very like different parts of India, not even India, different parts of world. Like for example, we recently had a meetup where there was a speaker who came literally from Germany, but obviously he wasn't here from Germany for this particular event. He had some other family commitment, but yeah, like he is there, right? So we could arrange his talk for that, and people were very happy to attend it. Like we had a speaker from Bangalore, we had speakers from different parts of India actually, and like from different like backgrounds. Like for example, someone is from the Kubernetes release team, someone is from developer advocacy team of some company, someone is from uh, like code development team. Like there were multiple avenues we actually focused on, and we kept it so like divided but integrated. People were very very interested and keen to learn about cloud native. So after that, I would also touch upon the personal branding we did for the reach we have right now. Like the college communities had a different kind of exposure, which was kind of internal. But for example, if we talk about cloud native communities, it's a bit like a spread out thing, right? So what we did was we actually collaborated with multiple colleges for events like college. We took college venues so that college people can come and hop in into our programs. They can learn more about cloud native. Like we kept it for free, obviously, because people so that people can come up from different parts of India, West Bengal to join our event, right? And struggle number two was low engagement and low reach. So initially what we did was we never had some engagement, right? We were trying to get some online sessions and all, but people were not very interested because they never knew what is cloud native. So I had that idea that we can do one thing, that is we can actually have the boot camp so that people are at least aware of what's actually happening. So now they have the access to the boot camp. Whenever someone comes up and says, Ronit, how can I get started? I just refer to them by the link. Go to YouTube and search for Kate Smasher's boot camp, and you are good to go. So this is how we created this pipeline, and people can just like loop in with us, right? And this is how we actually like shortened the gap between the community and the people who are actually keen to learn about cloud native and open source. And the second thing was reach, which was like the marketing and all, and which was actually covered after the boot camps by having offline events in colleges and in paid venues as well. So like offline meetups really help to like bridge that gap. Okay, so like we are also talking about the solutions, right? So getting into the CNCF ambassadorship program really helps. So how CNCF ambassadorship helps? They help you with logistics. They help you with the funds. They help you with the branding. If some chapter has CNCF ambassadors as organizers, they have a different weightage, right? It's very convenient for us to arrange everything. If we want some swags, we can actually have it because we get some like when we get onboarded, so we can distribute it among the students or among the members of the community so that they can be like a bit uplifted and they're more other boosted. So providing value to the audience, definitely this is one of the key factors behind everything. Like this is the main reason why we drive community events, right? So doesn't matter which community does it, but at the end of the day, the purpose is to uplift the community's ecosystem, uplift the tech ecosystem of the particular local chapter. Also, like to touch upon many things, like for example, Ritik goes to many foreign events, right? So what he does is that he learns something from there that, and like not all people are getting those like opportunities, right? Even if there are like possibilities to go there and attend those events, like not everyone is able to get into the scholarship program because the scholarship program is limited to very few people, and the cream layer gets that. So that then will the people who are actually in the local chapters will get nothing? No, that can't happen. So what we do is that we share the knowledge we get from those conferences. We share the swags, we share the insights, we share the referrals. In fact, some people from our community got into Big Four through referrals. Like it's a very big deal. And in fact, I would also mention that the person was not even from tech team of our community. He was in the design team, but still he got into a Big Four. So it was a really good a really big achievement for me. It felt like a personal achievement, but I don't know if Ritik knows about it, but we will talk about it later anyways. So that's the thing, getting into the CNCF ambassadorship, sharing about the program, helping network with speakers, and add a community partner. Like for example, if we have a college, right? Colleges have many communities. So what we do is that we collab with them. We have some events with them together. We onboard people from those communities, and like this is how people are getting added up in the community. So this is the thing. Anything else to touch upon? I don't think so. Okay, so struggle 3 is that community, but without community partners. So yeah, for example, if you're starting a new community, the challenge is that you won't be able to reach out to many people at a time. So why not taking the advantage of the existing communities? Network with people who are the organizers of like other communities who have the power to actually escalate your like posters or maybe some initiative or drive or boot camp or anything like that, maybe hackathon, anything like that to the other communities so that they can come up and participate, right? So we have focused a lot on the community partnerships as well. For example, we have worked with like the best of the best communities all over India so that they can actually send people from their community to our community and we can do collaboration. Like also, it is not just a one-way thing, it's also vice versa thing. Like for example, something good happens in that particular community whom we are collaborating with. So we are also encouraging people from our community to, hey, just participate. Why sitting idle? So this is how it works, right? The end result should be to get the most out of it. Doesn't matter which community does it. So yeah, and the solutions are pretty much simple. I have already discussed it. Community partner selection, community partners outreach, and these are the things. And I think the later parts will be discussed upon by Ritik. So Ritik, go
So
ahead.
now, thanks, Ronit. Now the problem is budget. So unit budget, wow. So add food, planning, logistics, right? How to get those? It's very simple. Like for us, CNCF ambassador was there. But again, you can reach out to companies, you can reach out to local community leaders as well. Because local community leaders know where are the people who are interested to sponsor small meetups. My company, for example, Loft Labs, we also sponsor events across India, and we are trying to expand that because we want to contribute more to the community because we understand the importance of community. So reaching out to people like your local community leaders and another companies who are very active in those places is very helpful. But next is uh, how can we make sure the attendance, the engagement, and the people are repeating? We just don't want them to have a one-time experience, right? We want them to come back again and again. And the solution is very simple, like building a community inside a community, building a forum, like using Discord or somewhere where people can come in, they can have some feedback, they can share what things went wrong, what things went good, so that can help us to improve the decision making as we grow. But again, keeping people updated through social media, like whenever we are doing something, like we are posting about our speakers, we are posting about the attendees, we are posting about the quiz, the swags, the venue, the people, the spotlights, we want them to be updated, right? Both in our Discord, both in our socials, because with that more people join in, more people are interested, and more people are excited as well. So this is a very simple way, like to make sure everyone is aware about what is happening. But moving forward, if you want to start your own community, what are the things we can recommend? First is reaching out to anyone you want, provide context, provide why you are reaching out, provide what things you want from them. Don't just reach out like, hey, I'm building a community, can you help? Just tell, hey, I'm building a cloud native community or some XYZ community. We are 50 people at start, but we don't know whom should we reach out for speaking so that we can provide more value. Be specific when you reach out, but reach out to people who are there because they can help you. Like for me, when I reached out to a person, they just connected me with a friend, and it was so simple. They next is find the shared struggle. When there is a shared struggle, your community thrives. The Cloud Native Google is here for more than a year right now. So if you have a shared struggle, that is simpler. And start off online. It's very okay to start an online community if offline isn't viable. Like this meetup is also happening online, but the impact it is creating is so good. Like people can go through YouTube and see the video. So it's completely okay if it's online because the end goal should be people should get value. And if you want more help, get into the programs like Cloud Native community groups because you can get more love, you can get more support, you can get an audience and a community who can help you do the things. So that is very helpful again. Lastly, if you want to just throw the stats out, we started last year from zero, but today we have around 726 plus members, 30 plus core teams, 6 plus events are done, 20 plus speakers, some are international, some are national in India from different states, few locals, and we are planning a hackathon. So if you see in a year, in a bit more than a year, we have achieved these numbers. And most of the people in our surrounding region knows there is a thriving cloud native Hooghly community. And if you want to like point on the reason is very simple. It is the people like those who are coming in together and helping us build one of the best communities in the region. This is a picture from our recent Kubernetes 10th birthday. So Kubernetes had a recent birthday, so we celebrated it. We booked a venue, we brought in a lot more people, and we did that. So it was awesome. And the floor is open for question and answers if you have any regarding community building, how to outreach, or anything if you have. Our socials were in the slides. Feel free to connect with us and uh, would love to answer your questions.
Great. Thank you for the awesome session. Let me remove the slides. Okay, so we have a question, although it's not oriented to directly community, but yeah, what skills should undergraduate students focus on to prepare for a career in cloud native? So as both of you are working with it, so I think that should be a good question.
Roy, do you want to go first?
Yeah, sure. So the thing is that if you are like just starting out with your cloud native journey, I would really suggest you to get done with the basics. For example, like if we call it basic, it's like basic Linux. You don't have to learn like hacking or stuff. It's just like basic commands which you are just required to get it done. And a bit of computer networking is very essential. And like these few things will be actually very helpful for you to get started with cloud native. And then also I would recommend you to get started with any like just blindfold yourself and pick any cloud provider. For example, if you want to great resources, you will find AWS to be very suitable, though the credits are very hard to find, but you can get it. But for example, if you want to get started with GCP, that's also good. Google, I mean. So like credits are very accessible, and the recent docs are very good. So like these are pretty much where you can start off with. And then you can actually slowly go inside. We can actually recommend you the Kate Smashers bootcamp we have. So if you want to get started, you can actually take a look into our bootcamp. We have some short videos on like the introductory parts. So if you just want to get started, that will be a good place to start with. And that's what we are for, just to get started with.
Uh, will we move? Let's move to the next question. I hope that answers your questions, Joynal. Okay, so what are some common misconceptions about cloud native technologies that you have encountered?
Ritik, please go ahead.
Yeah, like to be honest, one of the things is like if you are in a good community, you won't hear a lot of misconceptions. Like we were part of programs like CNCF ambassadors, and we had a good surrounding. So like uh, to have a good community around you, the misconceptions increase quite a lot. But again, one of the misconceptions that I hear a lot is like cloud native is easy and you can just go through cloud native without having a lot of fundamentals, which is very wrong because um, fundamentals can help you understand things more easily whenever you're growing in your career. Like the technologies, like a lot of CNC projects also come and go, but the fundamentals don't change. So focus, as Ronit was saying, focus on fundamentals like networking and all, Linux and all those things that can be helpful to build your build more, like build more knowledge in cloud, build more knowledge in cloud native. So a couple of things I can understand as a fundamentals is having some knowledge in cloud, self deployment, Linux, and all those things. So focusing on that is very important. All
Yeah,
good.
I hope that answers the questions. That's great. Oh, another question from Abu Sayed. Okay, what things you focused to introduce cloud native to the newbies so that they can explore a new path or platform rather than well-established ones?
I will go with this one. So, again, the answer to this is very simple: being intentional. So, whenever you are focusing on fundamentals, like focusing on how to deploy your application or something like that, you have a question like how to do that through a cloud, through Docker, through Kubernetes. So, just use one of those, and then you will understand the pitfalls of the previous ones. So, as you understand the pitfalls, you can understand how you can improve that. So learning paths are okay, but when you understand that Docker's like whenever a Docker instance goes down, you need to create it again. Then you understand the importance of Kubernetes. Then you understand the networking service mesh and all the things. So you need to understand why that those things are coming into the picture. And there might be a lot of things that you don't need to know that you will know in an enterprise setting, but things that you are learning right now by having that experience, that is how you actually go ahead learning things, by being intentional. And if it gets overwhelming for you, you can for sure use a path. Yeah, like there are a lot of free courses on YouTube, so use that. But again, just ask your question. The most important question I always ask myself is why I'm learning this, why I'm doing that, what will be the impact we created. So focus on why.
Yep, I hope that answers your questions. Okay, in the meantime, I'm actually adding the bootcamp link here so that you guys can check in, right? So let's go. Yeah, awesome. Okay, I think we don't have any questions. We can't see any questions right now. But yeah,
And
if you are okay,
yep.
you can take the. Yeah, Ritik,
Yeah,
you
and
were
thank you
saying
so much,
something?
Mintu, for hosting this and inviting us. It's such an
Yes.
awesome experience to see everything coming together.
Mhm.
Definitely.
Yeah, would have been
Likewise from
great
my side
if
as well. Thanks, Mithul.
yes, would have been great if we could meet in the KubeCon India. But
Let's
yeah,
see.
as
I hope
already
you get your
mentioned,
visa.
let's hope. But I can see actually two more questions. Can we take that?
Rohan, you want to go for the first one?
Yeah, sure. I'm okay with it.
Okay. After that, we will wrap the session. Okay. So, how does
Definitely.
computational thinking play a role in cloud native development, and why is it important?
Mm,
Computational thinking.
I'm not sure if this is relevant. I'm
Yeah,
not getting.
I also can't think that. Skip that for a while. What's that? How does Kubernetes integrate with other cloud technologies? I also don't think that that's much more technical.
But
Yeah,
but
Um,
uh,
like
but
I
I
can
can
give a
I can
simple
that
answer.
actually.
yeah, yes, you
Yeah,
guys can
Uh,
answer.
This
Yes,
one,
one can
this
answer.
one, this one actually at least seems like feasible. Okay, so the thing is
Yes.
that any cloud native tool you are seeing right now is around Kubernetes. So the entire landscape is around Kubernetes. Uh, like
and
for example, yep,
And the second simple
Ritik.
answer is think about Kubernetes as an operating system for cloud. So Kubernetes can run across any cloud. So your workloads can be native to any cloud. So it acts as a layer by which it doesn't matter where are your nodes at. Is it in GCP? Is it in Azure? So you have a layer over there, and anything you're building will work on the layer, despite of the infra between or below that. Infra can be anywhere on your private cloud, on your public cloud, on your self local machine. So yeah, that is a simple answer on how Kubernetes is cloud native and helping cloud native things, because it gives you a platform where you can have
Mhm,
anything over that.
mhm. Yeah,
Kubernetes
I
mainly
think we can.
handles everything. Like the
Yeah.
if like the infrastructure can be anything. Like it
Mhm,
doesn't care about the infrastructure. It will just work, and you need to just communicate with the API server, and the things will be sorted.
yeah, that's the benefit of Kubernetes. Yeah, thank you so much, Ronit and Ritik, for your time. And yeah, I think we can wrap our session then. Thank
Thank you
you,
so
guys.
much. Bye bye.
Yeah,
Thank you so much,
yeah.
Mithul.
Bye bye.
Bye bye. Take care.
Yeah,
Bye.
hope to.
Bye.
Yeah, hope to see you guys soon. Okay, great. Okay, so time to start our last session, and after that, okay. So we have another quiz. We don't have any quiz, but we have our feedback forms we will be sharing. So depending on that, those we will have two more gifts to give away, right? So make sure to attend these sessions. So after that, we will share the feedback form. And okay, so right now, the topic for today, this session is harnessing eBPF for advanced observability in Kubernetes environments. So for that, we have Nikolai with us. So let me add him to the stage. So hey, Nikolai, can you hear me?
Hi. Yeah.
Okay, awesome. Thank you so much for accepting, for speaking in the KCD Chattogram. So I think what you can do is you can start with by introducing yourself, and then we can start, right?
Yeah. Yeah. Can you share my slides?
Yes. Done.
Cool. Let's start. I'm Nikolai, CEO and co-founder at Karoot. And today I'm going to talk about zero instrumentation observability. And we will discuss this from eBPF perspective. Like a little bit notes about me. I am an ops guy initially, and I worked a lot on building reliable infrastructures. And from some point, I started to build observability tools and platforms, and now I'm focused on building Karoot. Karoot is an open source observability tool that covers all the aspects of observability in terms of metrics, logs, traces, and so on. But let's start from the very beginning. What is observability? From my perspective, observability is being able to answer a question about a system. These days, systems are getting more and more complex, and that's why we should be able to find issues and troubleshoot them quickly. We should care a lot about observability because we have to manage systems containing hundreds and even thousands of services. And why do we need that? I want to highlight 3 points here. The first one is availability. We can, if you're doing business and online business, we should make sure that our system is available for users. The second one is the performance of our system, because there are a lot of researchers that prove that response time, for example, or application latency impacts our user satisfaction and our revenue at the end. And the third one is cost. If we can optimize some of our services, allowing them consume less resources, we will spend less budget on cloud. And why I want to talk about zero instrumentation observability. From my perspective, it's super important because before, like, I'm a relatively old guy, and I worked in this space already when systems were super simple. We had dedicated nodes for our monolith application. They communicate with some databases, and that's it. So troubleshooting in such systems were pretty clear, and you need to check the application itself, its database, underlying nodes, and sometimes network. That's it. Really pretty straightforward. These days, we have much more complex applications. It contains a lot of services. We have distributed databases. We have Kubernetes that makes it pretty dynamic. So we have spot nodes that can appear and disappear. And in this, if we're talking about managing such systems, we should care about observability, because troubleshooting can be pretty tricky there. We should follow all the dependency graph and find the bottlenecks. That's why we should proceed some steps to make our system observable. What does it mean? The first step is collecting telemetry data. Any analysis should work on top of some data. In case of observability, we are talking about metrics, logs, traces, and sometimes profiles. Then we should store this telemetry data in some databases, scale them somehow. And the last step is we should learn how to extract meaning, extract insights from this telemetry data. And from my perspective, this is the most challenging part of all the process. But before we will talk about how to collect telemetry data, let's talk about what we need to collect to be able to answer questions. I wrote down some list, but it's pretty high level list. We should know about in terms of Kubernetes, think about every application deployment, every service, every component of our system. We should know about each component, like their service level indicators, like request errors, latency. We should understand how components communicate with each other. We should be able to build service map. Then we should control resource usage, like CPU, memory, disk. We should understand if there are any issues with CPU or memory or something like that. We should understand the status of our network, because in most cases, applications communicate with each other through network. And sometimes it can be pretty complex topology involving many availability zones and even regions. We should collect application logs. We should understand runtime environment such as JVM or .NET runtime or Golang runtime. We should also understand if we have any issues with placement, like orchestrator-related metrics such as status of our applications, like are there any pending pods and so on. We can collect all this data manually, but we should dedicate a lot of time of our team to instrument all the applications using OpenTelemetry SDK, using such various Prometheus exporters and so on. But in some cases, it's not possible, or it's pretty tricky to instrument third-party services or legacy services, because you can change their code. And in this case, we can think about how to gather all this telemetry data without the need to instrument and change our application code. And we have eBPF. Like, few words about what is eBPF. eBPF is a kernel, a feature of the Linux kernel. It allows you to write small program and run them in kernel space and ask kernel, okay, I know, please call my application when some new process appears in the operating system, or TCP connection is initiated. And the kernel will call our application, and we will be able to access this kernel function arguments and collect some data and send it to the user space part of our program. And one important note here is that eBPF just allows you to write code and run it. So it doesn't solve any observability or security problem itself. And it's really important to understand. And this is like top level overview of what you can do, what exactly you can implement with eBPF. Using eBPF, you can attach to any Linux kernel function call. For example, there is a function in kernel that initiates TCP connection, and you can attach to it, and you can access to arguments of this function and other context. Also, in some cases, using kprobes is not super stable, because in the kernel code, functions can change, their names can change, code can be refactored, or the arguments of function can change. That's why developers decided to embed some static trace points into kernel code. And for example, you have static trace points with some stable argument set, and you can, for example, trace system calls. System call, it's a call from user space program to kernel, like open a file, for example. And like trace points are more stable interface to deal with kernel. Next, we have uprobes. Uprobes allows you to ask kernel to call your eBPF program when some application level function call. For example, you can attach your program to like SSL write function of OpenSSL, and it like this code is executed in the user space, and it allows you to also access to your eBPF program to be triggered on this call. And there are some mechanisms allows you to keep some values between your program calls in the kernel space. And also there are some mechanisms that allows you to exchange, like send data from user space to kernel space and back. It's like writing eBPF programs can be challenging and pretty complicated process, and it's like sometimes it's hard to debug. But the good news are you don't have to write your eBPF program, since we already have a lot of open source tools that can help you to gather telemetry data, for example, Kahoot, without the need to write code. Our agent uses eBPF to gather various telemetry data about containers running on each node. It instruments like all communications between the containers. It measures network latency and do a lot of instrumentation that doesn't require any code changes. And it's open source, it's Prometheus and OpenTelemetry compatible. It can send logs and traces through OpenTelemetry protocol, and also expose metrics in the Prometheus format. And let's talk about low-level details on how our agent uses eBPF. First of all, it requires to be aware about all processes on the node. When some new process started on the machine, we should trigger some code and discovers container metadata, such as, for example, if it's a process is part of Kubernetes pod, we need to understand the exact pod, like namespace, pod name, container name, and so on, NC groups. And there's the groups to be able to gather like resource usage metrics. Also, we should trace process exit to know that this process is no longer exist on the machine. And sometimes we can mark, we can understand that this process has been terminated by the own killer, and mark the event that is the reason of process termination is out of memory event. And also our agent traces open file events to be able to discover container logs and to identify volumes or partitions that used by the container. Also, agent tracks all TCP communications between container. It tracks outbound TCP connections from every process to any TCP endpoint. And it also calculates the number of TCP transmissions to be able to understand, to identify situations where there are some packet loss between two particular containers. Then we want to capture protocol level, application level protocols such as HTTP, PostgreSQL, MySQL, and for doing that, the agent tracks syscalls that responsible for for write and read data from TCP sockets. And it's like we will cover this topic in more details. And our agent, like since eBPF requires any program to be like limited complexity, for example, you cannot proceed some complicated analysis right in the kernel space. And that's why our agent process each request or query in two steps. The first one is super optimized step in the kernel, and we like this data looks like an HTTP call, and the more complicated part is processed in the user space code, where we can extract HTTP headers or payload from the request. And let's take a look how it works from the kernel perspective. When we call some HTTP endpoint from curl command, the first we can see syscall that responsible for sending DNS query, then send message. Here we can see DNS response. Then we will see TCP connection event, and next we will send some data to the file descriptor 5, which is socket or TCP socket to google.com, one of their endpoints, and then we will see a response. So in this case, we can easily understand that, like using some markers, we can easily understand that HTTP communication happens here. And the kernel side, we have pretty like stupid and simple program. It uses some like it tries to detect HTTP communications through like matching most common HTTP methods, and it's like super optimal. It only reads like 16 bytes of the payload, and it's like low overhead call. And then when we see some response, we also can match for some markers and understand as, okay, we've seen HTTP request, and now we had a response. So, and between these calls, we somehow measured timestamps, captured timestamps, and stored timestamp, and now we can understand latency, status code, and so on. And these days, most of communications happen through TLS encrypted connections. And to deal with that, our agent use uprobes to capture SSL, OpenSSL calls, because if we track only like TCP level communications, we will see only encrypted data, and our agent uses like try to capture data between before it's encrypted and after it's decrypted in case of processing HTTP response. So we cover like OpenSSL code, and also since Golang applications use like native Golang's crypto library, we can also cover it with handling special function calls here. So it's like there are some details about how we can understand that the particular application or process uses OpenSSL library, but I don't think we want to dig into this right now. Let's talk about eBPF performance and guarantees that kernel provides us about performance. Because if we set up our agent, we should be we want to ensure that our eBPF programs will not impact our application performance. It's super important when we deal with production environments. And Linux kernel has like validates each eBPF program before it loads it, and your eBPF application should meet some criteria. For example, it must have a finite complexity. This means you cannot use like loops or something, and you are pretty limited in what you can implement in the kernel space. And also communication between your kernel side part of your eBPF program and user space part occurs through a ring buffer. So in worst case, if your application cannot read all the data on time, your buffer will be overridden, and you will lose some data. But if you're talking about metrics or traces, it's not a critical thing, because this trade-off works in this way. In worst case, you will lose some data, telemetry data, but you can have some guarantees that your application performance will not be affected by the eBPF program. Now let's talk about what we can see using data captured using eBPF. Here is some screenshot from our demo application. This is a Kubernetes cluster with some of services deployed into it, and they communicate through network. And we just installed our agents. That's it. We don't. We didn't do anything with OpenTelemetry instrumentation, and we can see big picture. Like it covers 100% of infrastructure. It can check all the communications between components. We can see how many requests performed within each component. We can see latency. We can see any errors. And it's really cool to have, because it can be achieved like in few minutes after the installation. Then, since we track all connections, we can see them not as an overview, but we can see communications between each particular containers. And we can see, for example, here Prometheus cannot connect to some DB components. And it's really cool because you can know exactly what's happening in your network. And like also our agent measures network latencies. Think about it like ping, but the ping measure latency each few seconds, and that's why you can understand like network condition between any particular containers here. Also, with eBPF, we track DNS requests, and we can measure their latency, their errors, and so on. So we can see which DNS requests are made by the particular container. And for example, if you have any issues with DNS servers in your Kubernetes cluster, you can see these issues like really quick. Also, the agent uses CBF not only for exposing metrics, but also for capturing traces. It can capture like individual spans and send them through OpenTelemetry protocol. So you can work with them in UI and see, for example, outliers. You can detect the particular database queries or HTTP request, or I don't know, Redis request, anything. You can easily understand the particular queries behind, outliers on the chart. But if you're talking about tracing, it's like eBPF implementation has some limitations. For example, we don't have any tracing ID. It should be originated somewhere. And in this case, we use eBPF generated traces as individual spans instead of like full feature distributed traces. There are some projects on the market that try to change your application payload and inject, like, if our agent acts like an observer and it doesn't change anything. Several products try to, for example, add some HTTP headers to propagate trace ID. Our agent doesn't do that, but instead Corud supports not only BPF-based telemetry, but also tracing data generated by OpenTelemetry SDKs. So it supports both, and that's why if you can't instrument some legacy service, you can use BPF generated data to understand its performance. If you can implement OpenTelemetry, instrument your application with OpenTelemetry, supports it. Also, we use eBPF for continuous profiling. It's super useful when you want to explain some CPU spikes. So eBPF is used like with some frequency. Our agent traces, like, collects stack traces of each running process on the node, and it can understand the stack, and it can provide us with flame graph. So you can select any CPU anomaly and explain it precise to the line of code. Also, you can compare like flame graph of some anomaly with flame graph, like, for example, 5 minutes before anomaly, and see the difference. It's really useful when you want to explain, like, if you see some CPU anomaly, you can explain it and see what happened there. And a few words about Corud architecture. We have Corud, the main component, which like UI and also collector. It stores telemetry data. It stores logs, traces, and profiles in ClickHouse, and metrics in Prometheus. Also, we provide users with our agents, and they you can use Corud as a OpenTelemetry backend for metric or for traces and logs. So finally, I ask you to try Corud because it's open source. It can be installed not only in Kubernetes, but also bare metal servers. For example, if you run your databases on dedicated bare metal servers or VMs, you can install the agent there and connect this agent with your Kubernetes clusters. And also you can instrument AWS managed databases with Corud's agent. Corud has built-in advanced observability for most popular open source databases. And if you want to have single pane of glass, and with Corud and eBPF, you can implement them in a few minutes. Just try it, and that's it. If you have any questions.
Thank you for the session. Okay, so we have a question. So let's start with it. So how does eBPF enhance Kubernetes monitoring compared to traditional methods?
Imagine that you have 200 services in your Kubernetes cluster. With OpenTelemetry, you will need to change and redeploy each service. With eBPF, everything you will need to install the agent, and that's it. You will have all this data without any code changes, deployments, and so on. You don't need to allocate time of your development team to obtain observability.
Okay. So if that answers your question, Joanal. Maybe. So let's wait for any other questions. So yeah, we have another one. What tools or frameworks would you recommend for beginners to start learning and experiment with eBPF?
If you want to start developing eBPF programs, the best way to start is the book of Liz Rice from Cilium team. It's like the comprehensive book about eBPF. So I can suggest this way. This as a starting point.
Okay. That can be a thing too for you. Okay, another question. So how does eBPF interact with the Linux kernel?
I hope I covered this topic during my talk, but yeah, you can load your eBPF programs and ask kernel to call them on some events.
Yeah, I hope that answers your question, Joanna. Right. So that was obviously covered. You can just check that out from the recorded video. Okay. So yeah, any other questions, folks? You can ask your questions right now. Also, another thing, as you mentioned, Kubernetes is open source. Is there any way to contribute to it?
Yeah, we are looking for new contributors, and we have everything right on GitHub, like initial contribution guide. We distribute code, using Apache 2 license. It's pretty open license, and if you like Karut, start us on GitHub. It also helps a lot because of we try to build our community.
Yeah, I think we have another questions. With that, we'll wrap our events. Okay. So how do you see eBPF evolving in the future, and what potential applications do you foresee?
I know that like eBPF is used in the observability space, in security space also, and in space managing network communication. For example, the most well-known eBPF project is Cilium, is a network. I don't know how it's called. Network. It's not a plugin. It's not network itself or Kubernetes, and they implement load balancing, network policy control with eBPF. So, yeah.
I think that should be it, right? With that, we can end the session, right? So yeah, thank you so much, Nicola, for your awesome session.
Yeah, thank you for having me.
Yeah, thank you so much. Hope to see you soon. Bye.
Bye.
Okay, so great. Okay, so great to see all of you. Okay, so I think we had issues with the form, right? The post-event form. Let me check that. And obviously, we have gifts to give away with the form, right? So wait a bit. Let me check that for you. In the meantime, if you have any questions, feel free to ask. And if I wrap up, like if I do mention about what happened today, you have seen like what are the things we have worked on. First of all, we started with the community, our program manager, right? She mentioned, uh, okay, wait, yeah, she mentioned about what this community is all about, right? Um, and she mentioned about the CNCF community, CNCG community, and others. Later on, she again mentioned about the KCD event. So today this is a KCD event, which is Kubernetes Community Day. Although it's totally not Kubernetes centric, you can't. It's not totally Kubernetes centric. It is totally like the cloud native ecosystem, right? So okay, kindly now use the link, and I think I've resolved the issue. Okay, kindly fill out the post event form. I'm sharing that again, and please let me know into the chat section. Like, okay, you have been able to. Okay, fill out the post event form. Here it is. Now you will have the access to use that. Use the form, you can fill it out. Okay, so let me summarize the things. So we started with the order session, automation of the community, and then we had Julia. So for the beginners, if you are here, if you can just check out the video in my YouTube channel. It's called Mitul Sharir. So there will be this live video available. So Julia basically mentioned about from the starting to the recent times, like how it evolved with the cloud native and the basic systems. If you're a beginner, totally, there were questions from the first year students like how to get into these. You can just check that video. That's good for us. That's good. After that, we had an Aditya, who is an engineer at CISDIC. Okay, so he actually introduced us with platform engineering, and also introduced backstage, right? Great. We had 2 sessions with platform engineering. So after that, we had Farjana Rahman. She mentioned about the from monoliths to microservices, basically focusing on microservices and Envoy, right? And after that, we had two folks like Adriana and Anna. So they mentioned about platform engineering as a whole. So previously we had a session with platform engineering 1-1, but still we had one session with platform engineers to get deep dive onto it. And then we had Ritik and Ronit Banerjee. So this is a thing I want to mention about basically their session. Till now we had technical sessions, but Ritik and Ronit's sessions were basically about the community. Now the thing is, it is important to understand the power of community. So it's basically KCD Chattogram, right? We have previously organized KCD Dhaka, which which was in Bangladesh back in May, right? So that's great. So we have currently one CNCF ambassador from Bangladesh, but you can actually apply for the program, right? So you can apply for the program and be part of the program, but you have to contribute a lot towards the CNCF cloud native ecosystem, right? So, but as a beginner, how can you start? That's the question. As a beginner, how can you start? So for me, how I started was contributing to CNCF glossary and Kubernetes localization project. So if you're a beginner, maybe from any other country, so this is localization project, which is non-technical. You can just go into Google and GitHub or something and just search for CNCF glossary. There are lots of projects which basically CNCF glossary is in a glossary. What we do is basically some sort of dictionary. It's not totally dictionary, but the cloud native terms are out there and they are described. Okay, so what you have to do, you can just translate in your local native language, maybe Hindi, maybe English. English is already there, sorry for that. Maybe Bangla, maybe Arabic, or so on. So you can start with a team, and you have to contribute. You have to do lots of files. You have to localize them, and then that page will be live. So gladly I started the initiative, so the page was live. That's great. After that, I started with the Kubernetes, one of the famous projects currently in the DevOps. So Kubernetes, the name is eventually Kubernetes Community Day. For the localization, we started, and the first one we started for the Bangla. And after that, we had Indian folks and obviously from Bangladesh. Eventually, we have Joinul here, we have Asim and Sajjad and so on. There are many, many contributors who started joining. And gladly, we did make that live. The Kubernetes Bangla page is live in... if you go to Kubernetes, you will see in the documentation there is a thing called Bengali or Bangla, right? So we made those live. So I'm sharing my experience because I'm the only CNCF ambassador from Bangladesh. So we have a lot of ambassadors in India. They get a lot of support, but Bangladesh we don't have. So I'm actually guiding you to be one. We started then what we did. So in my GitHub, we had a lot of work with the CNCF community. I was a maintainer as a whole. After that, I had a lot of work in the community in LinkedIn. I am part of lots of program, AWS Community Builder, Microsoft Gold Ambassador, GitHub Campus Expert, and lots of program and so on. So after that, I applied for the program. So it takes a lot to be a CNCF ambassador. So, and after that, we built this community. After that, I created the Cloud Native Chattogram and Cloud Native Dhaka. So that's how we started. And after that, after having lots of events in Cloud Native, then we had this KCD. Maybe you don't know about it. Maybe you have come to know about this for the first time. But you can be part of this journey. You can be part of the journey just like Ritik and Ronit mentioned. And they do travel to lots of countries. They have a lots of knowledge about DevOps, and they did mention Cloud Native is not for the beginners. So it is true. It's not for the beginners, but it is not, again, not only for the senior engineers. Okay, it's surely it's for you if you are in your college or university. Okay, so you can surely learn that, but obviously it will take 2 to 3 years at least. Okay, start learning, start contributing to our community. Yeah, that's great. Here you can see Asim Hamid has commented out here. So you can reach out to Asim over Facebook or GitHub. He will guide you for the CNCF localization contribution. Start with it, because when applying for the ambassador program, they check your GitHub profile, they check your YouTube, they check your LinkedIn profile, they check a lot. After that, you get the support. I know a lot of folks who applied but who got rejected, and that's the reality, because only the technical folks are not into these programs. They check a lot. So start with it, and there are lots of benefits. What are the benefits? I've shown you the KubeCon event, right? KubeCon North America, India, and so on. My tickets are free. Okay, eventually my trips are also free. So the thing is 75% discount, 90% discount, or the whole thing is free. I do get these offers. I'm the program committee member for KubeCon India. These things are pretty new. There are lots of engineers in Bangladesh, but these things are pretty new to explore, because they don't know about these opportunities. You can know about it. I'm still a university student and I'm exploring this, so you can do that. Don't think that the students can't do it. You can do it. It will take time, but you can learn the most toughest tech uh, out there. Okay, so let's get started. If you want to get connected, if you want to contribute, feel free to reach out. If it is a valid question, I'm always there. If it's a valid question, our community is always there. Okay, so thank you so much for being here. I can see 69 people live right now. It's 11 p.m. in Bangladesh, so that's like almost the end of the day. And thank you so much for being with us, and I hope to see you guys in any online sessions later on, and hope to see you guys in person as well. So feel free to let me know first of all in the comment section if you have filled out the feedback form. And let me know, yeah, you have filled out the feedback form. So from there we'll pick 2 winners. It basically depends on the questions. Also, we had few questions, right? I think we will check the questions and feedback form. Depending on that, we'll choose 2 winners, and as you will share your mail, so it will be easy for us to just mail you. And the other 3 winners, they have to reach out to our Facebook page, which is for Kubernetes Community Day Program. You can just reach out, share that, yeah, this is your name and this is the thing you own. So we'll share the screenshot. We'll then share you the Google form, and we'll ship the goodies to your home. Okay. So yeah, that was it for the KCD version. And unfortunately, we can't arrange a KCD next year. Maybe in 2026, we can arrange one KCD in person in Bangladesh. So I can't see any comment though about filling out the feedback form. Let me check out. Okay, I can see some responses. That's good. Okay, great. So I think with that, I can end our stream. If you have any questions, feel free to add that in the comment sections. Okay, so yeah, thank you so much, and hope to see you in any other videos, or maybe in my YouTube channel. Bye.